Okay.
بسم الله الرحمن الرحيم. لإيلاف قريش إيلافهم رحلة الشتاء والصيف فليعبدوا رب هذا البيت الذي أطعمهم من جوع وآمنهم من خوف.
Bismillahir Rahmanir Rahim. Praise to Allah, by whose grace the prayers are fulfilled, and prayers and peace be upon His Prophet, the caller to honor. Allah's blessings and peace be upon him, his family, and his companions until the day of judgment. Under the auspice of His Royal Highness Prince Khalid Al-Faisal, advisor to the custodian of the two holy mosques, governor of Mecca region, we welcome you to the International Conference on Logistics, which aims to innovate and improve global logistics efficiency and sustainability. His Excellency, the President of the University of Jeddah, Ma'ali Dr. Adnan bin Salim Al-Hameidan, Their Excellencies, esteemed Vice Chancellors of the University, dear guests, أهلاً وسهلاً بكم في المؤتمر الدولي للوجستيات برعاية كريمة من مستشار خادم الحرمين الشريفين أمير منطقة مكة المكرمة صاحب السمو الملكي الأمير خالد الفيصل.
القلب النابض، الموقع الجغرافي الاستراتيجي المميز، نتوسط به خطوط التجارة العالمية، نطل على بحرين حيث ثلث صادرات العالم من النفط تمر عبر خليجها العربي، كما أن 13% من تجارة العالم تمر عبر بحرها الأحمر، حيث تمتلك أكبر اقتصاد في منطقة شبه الجزيرة العربية وبلاد الشام والعراق، حيث تسهم بحوالي 38% من إجمالي الناتج المحلي و21% من تعداد السكان في هذه المنطقة.
هناك فرص كثيرة جدا في المملكة العربية السعودية في قطاعات مختلفة غير القطاع النفطي، في التعدين، في السياحة، في الخدمات، في اللوجستيات، في الاستثمار إلى آخره، فرص ضخمة جدا.
لذلك أطلق صاحب السمو الملكي الأمير محمد بن سلمان بن عبد العزيز آل سعود ولي العهد رئيس اللجنة العليا للنقل والخدمات اللوجستية حفظه الله الاستراتيجية الوطنية للنقل والخدمات اللوجستية التي تهدف لترسيخ مكانة المملكة مركزا لوجستيا عالميا يربط القارات الثلاث والارتقاء بخدمات ووسائل النقل كافة وتعزيز التكامل في منظومة الخدمات اللوجستية وأنماط النقل الحديثة لدعم مسيرة التنمية الشاملة في المملكة. إن تطوير القطاع اللوجستي يدعم النمو الاقتصادي من خلال الربط المحلي والإقليمي والدولي بشبكات التجارة الدولية وسلاسل الإمداد العالمية، وكذلك تعزيز الشراكة مع القطاع الخاص وتوسيع فرص توليد الوظائف. لذلك تتخذ المملكة العربية السعودية خطوات استباقية نحو بناء شبكة لوجستية واسعة النطاق ومنظمة بشكل متقن، حيث أطلق سمو ولي العهد الأمير محمد بن سلمان بن عبد العزيز آل سعود المخطط العام للمراكز اللوجستية بالمملكة، الذي يهدف إلى تطوير البنية التحتية للقطاع اللوجستي في المملكة وتعزيز مكانتها كوجهة استثمارية رائدة ومركز لوجستي عالمي. ويضم المخطط العام للمراكز اللوجستية 59 مركزاً بإجمالي مساحة تتجاوز 100 مليون متر مربع. وعليه أطلقت جامعة جدة استراتيجية مجال التركيز النقل والخدمات اللوجستية، حيث خصصت برنامج مجال التركيز لتقديم الأنشطة المرتبطة بقطاع النقل واللوجستيات في مجالات التعليم والبحث والابتكار والتطوير. وفي إطار استثمار الجامعة لممكناتها وقدراتها ورغبة في تسخير جهودها بما يخدم الأولويات الوطنية والمجالات الحيوية المرتبطة. ويهدف البرنامج الذي يعد أحد برامج رؤية جامعة جدة الجامعة السعودية الحديثة إلى بناء وتطوير القدرات البشرية المؤهلة في مجال التركيز وابتكار الحلول العلمية الرصينة للتحديات اللوجستية، ودعم ابتكار الذكاء الاصطناعي لبناء اللياقة التقنية وفق متطلبات الثورة الصناعية الرابعة، وتطوير خدمات التأهيل والتدريب المهني في التخصصات التطبيقية المرتبطة باللوجستيات التنافسية، وبناء الشراكات مع المكونات الوطنية في مجال التركيز. ويشمل برنامج مجال التركيز مجموعة من مؤشرات الأداء لقياس القيمة المضافة والأثر كمعدل الزيادة في الوزن النسبي لمساهمة أنشطة الجامعة في مجال اللوجستيات، ومدى مساهمة الجامعة في توطين قطاع النقل والخدمات اللوجستية في تطوير قطاع النقل والخدمات اللوجستية ورفع الكفاءات المهنية بجميع المستويات. اليوم يأتي المؤتمر الدولي الأول للوجستيات لترسيخ مكانة المملكة العربية السعودية كمركز لوجستي عالمي ومحور لربط القارات الثلاث، ونسعى فيه إلى تمكين الخبراء والباحثين والمبتكرين وصناع قرار سلاسل الإمداد لمناقشة الممكنات المعرفية والعلمية في المجال وتعزيز الاقتصاد السعودي وجعل المملكة مركزاً رئيسياً يربط بين القارات الثلاث، وذلك وفق رؤية المملكة 2030. أهلاً بكم في المؤتمر الدولي الأول للوجستيات المقام برحاب جامعة جدة.
We are pleased to introduce a speech by the Vice Chancellor for Academic Affairs and Development. ندعو الآن سعادة وكيل جامعة جدة للشؤون الأكاديمية والتطوير الدكتور مناجي بن حسن الكناني.
بسم الله الرحمن الرحيم. صاحب المعالي رئيس جامعة جدة معالي الدكتور عدنان بن سالم الحميدان، أصحاب السعادة، ضيوفنا الكرام، السلام عليكم ورحمة الله وبركاته. يسرنا أن نرحب بكم في المؤتمر الدولي الأول للوجستيات، والذي يجمع صناع القرار والخبراء والباحثين والمبتكرين من أنحاء العالم للمشاركة لتقديم أحدث الأبحاث العلمية والرؤى العلمية المستقبلية لتطوير مجال الخدمات اللوجستية. يعد المؤتمر الدولي الأول للوجستيات إحدى مبادرات الجامعة النوعية تحت برنامج البحث والابتكار كأحد برامج رؤية جامعة جدة الجامعة السعودية الحديثة، فيه نتطلع لتحقيق مؤشرات وأهداف الجامعة في محور بحث علمي لمكانة دولية، والذي يأتي لتعزيز مكانة المملكة كمركز لوجستي عالمي، ويجسد التزام الجامعة بدورها لتعزيز العلم والمعرفة ودعم الابتكار والتطوير في مجالات حيوية كاللوجستيات والنقل. ضيوفنا الكرام، تلقى المؤتمر الدولي الأول للوجستيات أكثر من 720 ورقة علمية من باحثين ومبتكرين متميزين من أنحاء العالم من 14 دولة. عليه تم تحكيم هذه الأوراق العلمية من لجان علمية متخصصة في 8 مسارات لوجستية دقيقة. يتواجد معنا اليوم عدد من الباحثين، ويقدم الجزء الآخر أبحاثهم عن بعد في جلسات علمية منفصلة بعد حفل الافتتاح. وسوف يتم نشر جميع الأوراق العلمية بالتعاون مع المعهد العلمي الدولي IEEE. يسعى المؤتمر الدولي للوجستيات إلى المساهمة في تحقيق تطلعات الاستراتيجية الوطنية للنقل والخدمات اللوجستية المنبثقة من رؤية المملكة 2030 من خلال تسخير البحث والابتكار لتطوير صناعة اللوجستيات بالمملكة العربية السعودية وبالعالم أجمع. فيه يتم إيجاد حلول علمية مبتكرة لتحديات في قطاع النقل والخدمات اللوجستية، وتعزيز الشراكات الدولية بين الباحثين ومؤسسات التعليم العالي. ختاماً، ضيوفنا الكرام، أتقدم بجزيل الشكر لرعاية مستشار خادم الحرمين الشريفين أمير منطقة مكة المكرمة صاحب السمو الملكي الأمير خالد الفيصل لهذا المحفل المبارك، ولدعم معالي رئيس الجامعة معالي الدكتور عدنان بن سالم الحميدان، وسعادة وكيل الجامعة للدراسات العليا والبحث العلمي سابقاً الأستاذ الدكتور عبيد المضف، وسعادة وكيلة الجامعة للدراسات العليا والبحث العلمي أستاذ هذا المؤتمر سعادة الأستاذ الدكتور شذا خصيفان، ولسعادة عميد كلية علوم وهندسة الحاسب، وسعادة وكيلة الكلية للبحث والابتكار لتنظيم هذا المؤتمر. كما أشكر حضوركم ومشاركتكم في هذا الحدث العلمي البارز، ونتطلع إلى النقاشات العلمية المثمرة والأفكار البناءة للمساهمة في تطوير قطاع اللوجستيات والنقل. والسلام عليكم ورحمة الله وبركاته.
Thank you, Doctor, for your insightful speech. This achievement reflects the dedication and motivation that led this wonderful team towards improving the quality of logistics. It is my honor to introduce His Excellency, the President of University of Jeddah. ندعو الآن رئيس جامعة جدة معالي الدكتور عدنان بن سالم الحميدان.
بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. ضيوفنا الكرام، ضيوف جامعة جدة، الزملاء والزميلات، السلام عليكم ورحمة الله وبركاته. حقيقة نحن اليوم سعيدين أولا بوجودكم، ثانيا إلى أن تصل جامعة جدة إلى هذه النقطة أن تنظم مؤتمرا دوليا متخصصا في مجال تركيزها وهو اللوجستيات. أنا أعتقد أن الجامعة جدة تسير في الطريق الصحيح لتبني هذا المجال المهم الذي يخدم أهم مؤشرات رؤية المملكة 2030. طبعا مجال اللوجستيات وكون المملكة تعتبر مركز لوجستي على مستوى العالم مهم، وهي ملتقى القارات الثلاث، يعظم الأهمية إقامة مثل هذه الفعاليات، ويؤكد على أنه من الضرورة الحية بمكان أن جامعة جدة تتوجه إلى هذا التوجه المهم بناء على أيضا موقعها الجغرافي الذي يقع على البحر الأحمر، وهو ممر ل13% من التجارة العالمية. اليوم القطاع اللوجستي هو من أكثر القطاعات نمواً على مستوى المملكة، ويتجاوز نمو هذا القطاع المعدل العالمي في نمو هذا القطاع وهو 12%. المملكة اليوم نمو القطاع يعادل 21%، فهو أكثر من المتوسط العالمي، وهذا أيضا دليل كبير على أنه المملكة جادة الحقيقة في توجهاتها بأن تكون مركزا لوجستيا عالميا. ربما هذا المؤتمر يراعي أو يتطرق لموضوع اللوجستيات من الجانب العلمي البحت، وهذه الأبحاث العلمية يمكن هي تكون مناسبات سعيدة لنا بشكل كبير كأكاديميين، لكن ما نطمح له في المناسبات القادمة أن يكون هناك الجانب التطبيقي أيضا بنسبة لا تقل عن 50% من إجمالي فعاليات المؤتمر ومواضيع المؤتمر، لأن هذا ما سيثري المؤتمر ويعزز العلاقة الحقيقة بين القطاع العام والقطاع الخاص، أو خلينا نقول القطاع البحثي والقطاع التطبيقي المعني أيضا بالقطاع اللوجستي في المملكة وخارجها على مستوى العالم. اليوم يمكن معانا في هذا المؤتمر نخبة من العلماء المتميزين من 14 جنسية مختلفة، وهذا أيضا يدل على أن هناك اهتمام كبير بهذا القطاع على مستوى دول العالم. معنا أيضا عدد من ورش العمل والفعاليات المصاحبة. أتمنى بإذن الله تعالى أن يكون هذا المؤتمر إضافة كبيرة لهذا القطاع على مستوى المملكة، وبإذن الله تعالى تكون هناك مخرجات وتوصيات وأبحاث علمية على مستوى كبير من التوصيات والنتائج التي تخدم هذا القطاع. طبعا في الختام أشكر كل من عمل على تنظيم هذا المؤتمر، كان عمل كبير الحقيقة، فترة طويلة من الزمن تم التنسيق لهذا المؤتمر وجمع هذا الحشد من العلماء والباحثين لإلقاء أوراقهم العلمية. شكر خاص لصاحب السمو الملكي الأمير خالد الفيصل مستشار خادم الحرمين الشريفين أمير منطقة مكة المكرمة على رعاية هذا المؤتمر، ولا شك أن هذه الرعاية تؤكد على حرص حكومة خادم الحرمين الشريفين على الاهتمام بهذا القطاع ودعمه ومساندته. وبإذن الله تعالى سيكون هذا اللقاء الأول ولن يكون الأخير، وسنلتقي دوما بإذن الله تعالى في ملتقيات تختص وتهتم بمجال اللوجستيات، مجال تركيز جامعة جدة. جامعة جدة جادة في هذا المجال بإذن الله تعالى، وسنصبو إلى هدفنا بدعمكم وتعاونكم سواء باحثين سواء قطاع اللوجستيات الحكومي والخاص. فشكرا على حضوركم وأتمنى لكم يوم سعيد في جامعة جدة. شكرا لكم.
Thank you for joining us on this exciting journey. Now we will launch the Logistics and Digital Transformation Business Platform. نستأذنكم الآن يتم تدشين حاضنة أعمال اللوجستيات والتحول الرقمي. We introduce the panel discussion for the National Strategy and Transport Logistics presented by Dr. Mohammed Al-Garni, Dean of Research and Innovation at the University of Jeddah. Our panel includes Dr. Khalid Al-Jahani, a logistics service expert and faculty member at the University of Jeddah. And we would also like to welcome Dr. Gosia from the National Institute of Technology, and Dr. Al-Ali, an associate professor at the Health Management Department at Liwa College. We would also like to invite Dr. Jamil Kutbi.
بسم الله الرحمن الرحيم. معالي رئيس الجامعة، سعادة الوكلاء، ضيوف جامعة جدة، نكرر الترحيب بكم في رحاب جامعة جدة في المؤتمر الدولي الأول للوجستيات. Allow me to speak in English given that some of the attendants are non-Arabic speakers. The main goal of this panel discussion is to talk about logistics from a strategic perspective, from the local, from a Saudi perspective as well as a global perspective. But I'd like to start, this is a discussion that has been had in many places. The word or the term logistics could mean different things to different people. So I'll take the opportunity, having some of the world experts with me on stage, to start by defining logistics so everybody are on the same page in what we mean by logistics, because it could have different meaning. I'll start with you, Dr. Khalid. If you could just briefly describe what logistics are as a term.
Sure. Touching from, I would say, the operational perspective, quite often people think of logistics as trucks and warehouses, which is right, but usually operation directors of logistics companies, they strive to simply achieve 7 things. How can we get the right product to the right customer, to the right place, at the right time, in the right quantity, right quality, at the right cost? So it's not only getting the product there. So this is, quite often sometimes people underestimate the value of logistics.
Thank you very much, Dr. Khalid. Dr. Haytham, if you could elaborate a little bit further,
sure.
Especially coming from a medical or a medical perspective. I know logistics plays a massive role. So in medicine or in a healthcare sector, when we say logistics, I'm sure there are different aspects that are not necessarily present in our mind when we think about logistics.
Sure. Bismillah ar-Rahman ar-Rahim. Actually, we look at logistics from a practical side more than theoretical side. And we look at logistics from 3 angles. First, from like suppliers and the government rule regarding the regulations and policies, and also from the customer side. During COVID-19 pandemic, we witnessed actually the real importance of logistics in our world. Many patients suffered from of many items. There is a loss of many items. There is shortage in human resources, shortage in suppliers, shortage in medical and non-medical items and materials, which is actually impacted the human being. When we talk about logistics from other industries, we talk about something less important than human being health, actually. So logistics in healthcare sector is the most important thing, and we need to cover all aspects of logistics from actually from this manufacturer side to make it domestic, national-wise. Okay, not only importing and exporting materials, we need also to govern the relationship and also build another partnerships with all parties in this equation.
Thank you very much, Dr. Haytham. Dr. Jamil, given your perspective and background in lean operation and lean organization, what does logistics mean in terms of lean organization?
Thank you, Dr. Muhammad. I guess it's basically the ability to move products from point A to point B, going through a network of some transportation modes, some hubs, which could be warehouses and fulfillment centers and manufacturers. So from the lean perspective is the ability to do all these functions with reducing waste in all aspects of this chain. So looking for all aspects, all types of waste, which can hinder that three kinds of flow, which is really essential in all supply chain: information, money, and goods. If you can manage all these three kinds of flow, then you have the ability to move those products from the origin, from the supply side, to the demand side in the shortest way, with the least cost, and in the right quantity, as Dr. Khalid said.
Thank you very much. Now, moving to the strategic perspective, given how important logistics is for Vision 2030 and for Saudi in general, I would like you, Dr. Khalid, if you could just give us an overview of the development in logistics sector in Saudi, just given how much research you spend looking into the development initiatives, projects. So if you could just give us a brief overview of the sector within Saudi.
Sure. Right now, I think the good thing is that we have actually a compass. We have a North Star that we can work towards, which is the National Strategy for Transport Logistics, the INTELIS. And it provides very specific measurable outcomes that all the transport ecosystem is working towards achieving. And definitely, the University of Jeddah is a strong pillar in, inshallah, enabling those goals. Right now, the ecosystem is working towards making Saudi in top 10 in LPI, which is the leading global framework, measuring all the logistics sector across the globe. Right now, we are at the 38th position. So within 7 years, inshallah, we'll be not only in the top 10, we'll be one of the leading sectors. Right now, all the ports for Saudi, they handle on a yearly basis about, for example, 10 million containers. And to give you a perspective, in a container, you can fit almost, so to speak, about 20 different fridges. The goal is in 2030, inshallah, to handle about 40 million containers. So that's 4 times more. Airports right now, they handle about 850,000 tons. The goal is for almost 5 times more. So it's not only numbers that we're achieving. We want to be the linchpin of logistics in the region. We want to be the place, the country, this industry that all logistics companies, when they talk about logistics, they will talk about, inshallah, Saudi as much as they talk about Singapore, Germany. So all those, I would say, entities in the ecosystem are working towards achieving this goal. And I would say a strong pillar is the human capital. And this is where, inshallah, in the University of Jeddah, will be a strong enabler in achieving this number, inshallah.
Thank you very much, Dr. Khalid. And just drawing from Dr. Khalid's answer, he mentioned Singapore, China, other world-leading countries in when it comes to logistics. And that I'd like just to make things more interesting. If you could, Dr. Haytham and Dr. Jamil, starting with Dr. Haytham, name a landmark projects that makes you excited to know about, whether within Saudi or outside of Saudi. It just would give us a perspective on how things are being developed.
Okay, actually, especially I'm talking about exactly at healthcare importance, as I mentioned before. We already in process in registering a patent regarding how to deal with food industry, tracking every single item in the food industry, included in what we call a smart health inspection. So smart health inspection started from the manufacturer side, or even actually at the agricultural side, using natural material to feeding plants, and also transportation, storage, tracking every single thing, and connect that system with the maps, and give every single stage of this process with a specific ID connected with artificial intelligence system. This gonna be like a good step forwarding that to govern and also control and maintain. Also, the most important is maintaining supplying of food during COVID, or even nowadays we have like unstable region. We need to plan not only for 1 year or 2 years. We need to plan strategically for such things.
Thank you very much. I do agree. Anything that do with food is of quite importance. Actually, the latest reports put food shortage as one of the highest risk facing the world in 2024, 25, 26. So anything that will sustain.
And doctor, of course, there is the most important is the healthy of that food, not only supplying food.
Definitely. Dr. Jamil?
As an objective observer, but before that, as a proud Saudi, I guess I'm really excited about so many projects, because what's happening right now in Saudi, it's a big workshop, especially in logistics and supply chain. But one project, which is a huge project and is going to connect all parts and all dots together, which is Al-Jisr al-Barri, the national railway or the national network, which is going to connect different parts of Saudi. It's starting from Yanbu port, coming down to King Abdullah's city, economical city, coming down to Jeddah's Islamic port, going to Riyadh, going to Dammam, going to Al Jubail, and lastly to Ras Al Khair. If you look at that network, it consists of 5 ports, 3 airports, and 14 logistical hubs. So what is it basically? It's the nervous system. It's going to be the nervous system for all logistical projects in Saudi. This project is going to take around 7 to 10 years to finish, inshallah. Parts of it is done already, but right now they are at the final stages of finishing the master plan for the project and giving it to certain consortium of different countries coming. Basically, right now they are thinking about a consortium from China. Is going to cost, the capital invested in that project is going to be around 120 billion riyals. So it's a humongous project. Which is going to do a very big shift, not locally. It's a global network. That's what's going to, when we think about connecting the east to the west, there is the sea routes and there is the railways. So the economical gate and the Silk Road. This network is going to connect the east to the west practically. So let's think about the Gulf states. The Gulf state is going to connect basically the Gulf state to Saudi. It started already with Emirates, and it comes from Abu Dhabi's part. That side is done, and the Saudi's part is working right now. It's going to connect Ras Al Khair to Kuwait, to Iraq, to Turkey, which is Europe, so you're connecting to Europe. So that's gonna do a very big value, added value, to the whole network of logistics globally. So I'm excited really about this project.
That's impressive. And as you see, everything is connected. Like, sustaining healthy transport of food, for example, that project, that massive project would definitely help in that. I'm a moderator, so I shouldn't be answering, but for this question, I would take the liberty and add one project that I'm most excited about. It's the Oxagon, which is the port within NEOM. What they said is, if we use the state-of-the-art technologies that already existed in the world, it wouldn't help us to achieve our vision. This is how visionary that port is. So I know, the development in logistics is fast growing, and that leads me to the last question in our panel discussion today, which is the future of logistics. I would like to get your perspective in the future of logistics, be it from an opportunity perspective, risks perspective, technology perspective. Dr. Haytham mentioned AI, and there is no conversation now without AI. So I will start with you, Dr. Haytham, this time. What is, in your vision, the future of logistics? As I said, opportunity, risk, technology, etc.
Sure. Actually, risk is very high for logistics from many sides, from the supplier, from the route, from the environment, from the political side also, from many sides. The most suitable solution might to go through agile logistics. We need to be agile, flexible, ready, prepared for any change in the environment, business environment, and even the political environment nowadays. So the agile supply chains and logistics actually is the best solution. We need to invest in technology, high advanced technology, tracking, listing, prioritizing also suppliers, customers, governed by rules and regulations came out from the governments. Also, we take also the responsibility. We should take our responsibility to human being side also. That means we need to look after the quality of products, the quality of supplies that we need. Not only just supplying. We have a lot of items or products in our markets, for example, but at what extent that products meet the standards, the quality. So we need a comprehensive, agile supply chain and logistics system. Thank you.
Thank you very much. Thank you very much. Dr. Jamil, if you could just give us an overview of the future of logistics from your perspective.
Well, I guess it's after what happened 2 years ago in Corona, we had big lessons, and these lessons, I guess we learned a lot about what happened there. The big learning point is moving from globalization to localization and adding the local content, reducing the risk in essential industries, medical, pharmaceutical, military, and food industry. Those sectors has to be managed in a totally different way during and especially after what happened in Corona. So if we talk about technology and localizing technology, 2 years ago, His Excellence Engineer Abdullah Sawaha, the Ministry of Communication in Saudi Arabia, announced that Saudi produced the first semiconductor in King Abdulaziz city in Riyadh for technology. That's a huge leap. It was announced in the LEAP conference 2 years ago, and it's a huge leap for Saudi. Because if we think about those semiconductors or chips, we know that it's the nervous system, it's the brain for all technologies that we use nowadays. It's operating our houses, all devices in our houses, and it's operating all the supercomputers that we use nowadays, and even in military, in airplanes, aircraft, all of that. So what happened in the shortage during the conflict, the geopolitical conflict between the US and Taiwan and China, let's say, and what was happening in Taiwan, it put a big risk right now on the supply for these kind of products. So localizing it and producing it for the local demand right now is essential, and the project is moving on, and there is a big consortium is going to be happening and big investments, so it is going to be going through in the following months, as I know.
Okay, thank you very much, Dr. Jamil. So we got agile logistics from Dr. Haytham, we got from globalization to localization from Dr. Jamil, Dr. Khalid, the final look at the future of logistics.
I think when it comes to the future, let's talk about our own future, where we will be, inshallah, in 6 years. When we, inshallah, host the 6th logistics conference here in Jeddah in 6 years from now, I expect, inshallah, the logistics sector in Saudi Arabia, where it will be, inshallah, multimodal transport. Right now, we hear about moving freight or moving cargo on rail. Very often people don't realize that in Saudi Arabia, we already actually have railway. Last year, SAR was able to move 25 million tons of product from Ras Al Jalamid to Ras Al Khair. So this is almost about 8%. Imagine with the opening of the 59 logistics zones, how much we can move. Automation. Right now, Singapore port, they're considering or they're implementing a fully automated terminal that will be able to handle about 65 million containers. Right now, they handle about 30. So this is almost double. People don't realize, Feritzi Gate Terminal in Jeddah, which is one of our partners, the University of Jeddah, they already have actually automated container movement where people with the joystick, they can offload and move products. So automation, AI, integration is coming. The last point, the future. Future logistics is highly technical people. People, young generation, they need to actually improve the skills. And I believe this is why I say always, we are actually proud from the University of Jeddah, why we are a pillar, because we are offering all those technical and professional education through our collaboration with TGA, with NIDLib, even through the different colleges where we offer all those different programs. So the future is ours, inshallah. I suggest that we immerse, we involve. Let's, inshallah, work all together, where 6 years from now, we'll be, inshallah, not only celebrating those milestones, but we'll be talking about them, inshallah.
Thank you very much, Dr. Khalid. That's a very hopeful note to end our panel discussion on. Thank you, Dr. Khalid, again. Thank you, Dr. Haytham, Dr. Jamil. I hope that we had the chance to shed some lights on the development of logistics, what logistics is and from different perspectives, as well as the future of logistics, which will always remain hopeful. Thank you very much for your listening, and talk to you, inshallah, next year in the logistics, and 6 years from now, where we discuss what Dr. Khalid has said. Thank you very much.
Thank you.
Now we will present a presentation titled A Roadmap for Electric Trucks in Freight Transportation, led by Dr. Ahmed Al-Lahyani.
Assalamu alaikum. It's a pleasure to be here. Bismillah ar-Rahman ar-Rahim. I'll be presenting today a presentation titled An Effective Roadmap to the Effective Integration of or Adoption of Electric Trucks. The agenda of the presentation is an introduction, benefits, challenges, and opportunities. Then how are we going to enable the effective integration of electric trucks? Then an overview of the leading manufacturer and key trials of electric trucks. And then I'll talk about the optimal use of electric trucks in freight transportation. Last, I'll include concluding remarks. The land freight industry is important in modern societies to transport goods, to interconnect different regions, and it's important for businesses. However, there is an adverse environmental impact on freight transport. For example, a heavy-duty truck produces 223 tons of carbon dioxide every year, which is the equivalent of a carbon footprint of 14 people. Therefore, this is the first motivation to transition from diesel-based trucks to electric trucks. Another important factor or motivation is energy efficiency. For example, the grid-to-drive energy conversion efficiency of electric trucks is 77%, whereas on the other hand, the internal combustion engine is from 12 to 30% of energy conversion efficiency. However, the matter is not only replacing the internal combustion engine with batteries and motors. It involves installing charging facilities in warehouses at strategic locations such as warehouses, truck stops, distribution centers, in addition to installing fast charging facilities on highways. Another important point is we need to coordinate the charging of the electric trucks in order to prevent grid overloading. Now I'll be talking about the benefits, challenges, and opportunities and risks of electric trucks. Obviously, one of the most important benefits of electric trucks is the reduction of CO2 or emissions. As you can see, if we transition to electric trucks, we can achieve zero carbon emission, and we can reduce on average 40 tons of CO2 emissions. Another benefit is reduced maintenance. Usually, mechanical parts tend to fail faster than electric components. Therefore, if we move to electric trucks, we can reduce the maintenance cost on the operation of the truck. Another important point, if we remove all the moving parts of mechanical moving parts, we can achieve more noise reduction. This is very important in cities where noise pollution is an issue. Now I'll be talking about the challenges of transitioning to electric trucks. One of the most important challenges is the insufficient infrastructure. If we don't have charging facilities installed, this can affect in logistics the operational schedule, and it can cause less profit margin. Another important challenge is the range anxiety and recharging times. The current battery technology for freight transport can drive up to around 600 kilometers or miles, 500 miles. For example, refueling a diesel truck may take 15 minutes, whereas recharging an electric truck may take up to 2 hours. Definitely the high cost, upfront cost. Batteries are expensive. They account for 40% of the cost of the electric trucks. Therefore, we might have higher initial investment. Another important challenge is the payload constraints. The existence of the battery on the electric trucks can weigh up to 27%, therefore can reduce the payload of the truck up to 15%. Risks, one of the most important risk factors is the power grid. There is an important point: if we adopt electric trucks and electric vehicles faster than the upgrade of the grid, it can cause problems. For example, in Europe, the upgrade will require our electric trucks will require 170 gigawatt hour and 800 gigawatt hour in North America and China by 2035. How did Europe solve that? They need to install 21,000 more wind turbines to help in the grid overload. Dependence on the supply chain of batteries. We know since after the COVID, after the pandemic, there was a disturbance in the supply chain. Usually electric batteries are made of lithium-ion batteries, and they exist in China, Argentina, and several other countries. And we will be dependent on that supply chain, and this could cause risks. Infrastructure, therefore we need to do planning for grid connections, parking, driveways, and charger locations. Finally, access to certified maintenance and technicians. If we are transitioning to electric trucks, we need to develop workforce and include more facility or maintenance facility centers that are trained to do maintenance for electric trucks. Now, how do we enable effective adoption or integration of electric trucks in the logistics sector? First, we need to develop, or governments need to develop supporting policies, such as truck emission standards, financial incentives, making obtaining permits for charging stations easier. And also, we need to invest more in renewable energy and charging infrastructure. Second thing is we need to collaborate all stakeholders together. It's not the responsibility of a single entity. Therefore, manufacturer, fleet operators, energy providers, and governments need to sit together and talk and organize how we are going to facilitate the adoption of electric trucks. Technological innovation, we definitely need to do three things. We need to increase range, reduce charging times, and improve payload capacities. We need to invest more in providing or inventing higher energy density batteries, higher energy density charger, power electronics, all of that technological advancement we need to invest in and work on. Now I'll be talking about the leading manufacturer. What are the electric trucks that exist in the market? As we all know, Tesla has a semi-truck. It's well known and it has been publicly available. And the loading capacity of the Tesla semi-truck is 37 tons. And it can regain up to 70% of its energy in 30 minutes. Another example, and the single charging range is at 500 miles, which is equivalent to 800 kilometers. Another example is BYD from China, the 8TT electric semi-truck. The loading capacity is 47 tons, and it can regain up to 100% of its energy within 2.5 hours. The range of this vehicle is around 325 kilometers. The last example we have here is the Volvo from Sweden. It has multiple electric trucks such as the FL Electric, FE Electric, VNR Class 8. It can carry up to 37 tons of payload at full capacity. And it can regain up to 80% of its energy within 90 minutes. The range of these vehicles are around 442 kilometers. Now, what is the optimal use or what's the realistic use of electric trucks in the logistics. We believe that we recommend using electric trucks within cities, especially between logistics facilities and container transport and operations around ports. Another thing we recommend is the last mile delivery. Electric trucks could be a good solution in this area. Now I'll put some examples on the best practice or the existing practices of electric trucks in the world. One example is DHL. It used Renault Kangoo Z electric delivery van in Europe and in Australia. And their aim is to achieve or to transition to 70% electric vans by 2025. Another example is Amazon. Amazon is using electric trucks from Rivian for delivering goods within American cities. The goal of Amazon, the partnership with Rivian, which is a well-known electric vehicle company, to add up to 100,000 electric delivery vans to its fleet by 2030. Another example is Volvo tested a 40-ton FH electric truck to measure its energy efficiency compared to a diesel truck on one of highways in southern Germany. What are the outcome of this experiment? They stabilized the speed of the electric trucks to 800 kilometers per hour, which is equivalent to a diesel truck. In conclusion or in summary, the truck proved to reduce or save up to 50% in energy consumption. Another conclusion they have that the drivers expressed their comfort due to the non-existent of the noise pollution or noise reduction, basically. Concluding remarks, governments, manufacturer, and logistics companies need to collaborate and invest in infrastructure, develop standards for electric charging. They need to ensure the availability of service centers and certified technicians. They need to minimize risks associated with global battery supply chains. And also, they need to train and develop technical capabilities to maintain these vehicles. Last, they need to encourage continuous technological innovation in trucks, technologies, and systems. The growth of electric trucks environment requires government entity to focus on providing regulatory support, invest in developing infrastructure for electric charging and renewable energy, improve the capacity of the electric grid, and promote and invest in the use of renewable energy resources. An important point that the cost of batteries and charging power electronics is increasing or decreasing with time. Therefore, the electric trucks can be similar in cost to the diesel trucks in the future. And this presentation was a brief summary of an extended white paper that was published last October. You can reach out to me or any of my authors or the fellow authors for more information. Thank you for listening.
Thank you for your presentation. We have a break right now for around 15 minutes. Logistic information systems in room 1, traffic and transportation logistics management and policies also in room 1, and general logistics in room 2, supply chain management in room 3.
Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Ala Abdul Majid Ashmawi, an associate professor from the Department of Cybersecurity at the College of Computer Science and Engineering, University of Jeddah. I'll be acting as a chair for today's logistic topic session. Each paper will be presented in 10 minutes, followed by a 3-minute question and answer session. The first paper, The Impact of Failure Demand on Flow in R&D, will be presented by Jamil Kutbi. The paper discusses today's fast-paced business landscape, where companies face relentless pressure to innovate and deliver new products quickly. This study examines how failure demand impacts R&D flow, revealing key areas for improvement that are crucial for enhancing R&D efficiency. Jamil Kutbi, please.
السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا ونبينا وحبيبنا محمد وعلى آله وصحبه أجمعين. Hello everyone. My name is Jamil Kutbi and I'm going to be presenting my paper, The Impact of Failure Flow on the Failure Demand on Flow in R&D. A brief introduction. What's been happening these days. A big talk regarding innovation and enhancing and fastening the cycle from research and development into and moving those products into the market. So today's competition is focusing mainly on how to shorten this cycle and to launch more products to the market compared to competitors. So it's a new level of competitive advantage that companies are using and utilizing in every aspect. And the point of what's happening is reducing the waste and fastening all kinds of waste in the R&D processes so you can have more efficient operations and more innovative products throughout this chain. So as seen that the biggest root cause of failure in many companies is writing on investments where there is no other variable products in the pipeline. So you're going to be risking your budget because if you have a single project or a single product, if it failed, you don't have any alternative, which puts you in a bad situation. The aim of the paper is to investigate the impact of failure demand on flow in research and development through observing the current situation and to assess the impact of failure demand has on product and development. The gap is that lean product development has got some limitation, especially in measuring and putting an index to measure the failure demand. So the concept of failure demand, we're going to be discussing and explaining all kinds of failure demand in product development. So there are 8 kinds of failure demand in new product development: chaotic work environment, lack of resources, functions, prioritization of project and tasks, lack of early consideration and manufacturability, over designing poorly defined product requirement, and email overload. So these 8 kind of failure demand are part of the literature review that's been done. In addition, the causes of dysfunctionality in new product development, there are 12 causes of dysfunctionality in new product development. Some of them are obvious: underutilization of cadence, worship of efficiency, failure to correctly quantify economics, institutionalizing of large batches, and centralizing control. And other aspects would cause dysfunctionality. So the main 5 causes of failure demand, as stated in the literature: failure to innovate, failure to meet customer requirements, and over-engineering. In addition, failure to manage portfolio, and failure to integrate suppliers and third-party innovation, and lastly, failure to create flow. My methodology that I use in this paper is a deductive methodology. I use a quantitative research method to answer many questions. It was an online survey to collect the data. The survey was sent. The internal network consists of 322 employees, in which 133 completed the 3 sections. If we think about 237 clicks, they clicked on the link, and either they finished it or saved it, which puts us the response rate to 58.2%, which is satisfactory for the data. The survey consists of 2 main sections for this paper. The first section is participants' portfolio profile and in their company, and the second part consists of 24 questions which cover all aspects of failure demand, so customers' requirement and needs, stage gate processes, flow, portfolio management, rework, retesting, validation, program management, knowledge conversion, and metrics and measures. So these are all 24 questions are related to these 8 kinds of failure demand. So let's start with the results and analysis. We see that responses profile, the majority were from the development organization, followed by 64 from the supply chain. Additionally, the majority of participants, part of them are from director and above, 46 participants, and 62 managers, and the rest of the organization, 94 employees. If we divide them regarding who was in new product development or none who belong to the company MP or doesn't belong to the company, so the majority, 137, are from the company. This is a summary of the 24 questions that been answered. It's an agree or disagree questions. I ranked them with the highest to the lowest. So the red reflects the disagreement and the blue reflects the agreement. We'll go through some of these questions and highlight some of the insights which is important. So here I ranked the impact of failure demand by the highest impact to the lowest impact. And we see that the most impactful kinds of failure demands are poorly defined customer requirement, and then rework and revalidation and retesting, and then failure to meet requirements once defined, and fourth, portfolio management, and so on. What I really would like to focus on is I will go back. That's a matrix which link the failure demand ranking and the impact on R&D. It's clear, as you see on the top right corner, that the top 4 failure demand that has got the highest impact is the customer requirement, rework and retesting, portfolio management, resources management, and program management leadership. Those 5 most impactful failure demand on the performance of research and development. Let's take the most impactful and the highest 5 failure demands that I'd like to discuss. The first one is customers' needs and requirement. It was clear from data that the majority of respondents believe that organizations are close to their customers and work diligently on trying to identify their needs. However, they struggle to translating these needs to a clear set of requirements that product development teams can deliver. Additionally, the documentation for bureaucracy that involve requirement management leads to a high level of queuing, patching, development in process, and poor feedback, and all of this inhibit flow through the product development. Secondly, we'll discuss the portfolio management and failure demand. 80% is a higher percentage. 80% of respondents of the opinion that they have an ineffective portfolio management process. That's what's going to limiting the ability to innovate in the organization and resources allocation, which impact the available funding, strategic imperatives, market segmentation, aligning the technology roadmap, and awareness to competitive landscape and leadership with decision-making ability. Thirdly, the stage gate, very insightful and clear observation due to the majority of respondents feel that it can be improved with 78%. So the stage gate is hindering the flow in the research and development department. 60% of individual contributors feel that there is a high level of rigor applied to stage gate review, whereas only 25 directors share this view. Fourthly, program and resources management. Majority of respondents believe that their internal program management system are ineffective and their internal resources loading and tracking system. And lastly, the rework and retesting validation. 80% of respondents in the survey see that there is a significant source of failure demand and seen as a second only to poorly defined customer requirement. Significant failure demand has been created either individually by rework, retesting, or revalidation, or combination of the three. Let's move to the conclusion and recommendation. The main conclusions: modes of failure demand, such as failure to meet customer requirement, ineffective portfolio management, and rework retesting, were very prevalent. Influence on the stage gate process and development in process were not impactful as MPD performance. And thirdly, adoption of the incorrect business model, poor product life cycle management, and organization cultural dynamics were very strongly articulated through participants' comments. And one comment that throughout the research was the inability to desire the scene of senior management to see the waste in new product development. And lastly, the limitation of the research. We're going to be developing a matrix which is going to be measuring the failure demand and spreading and verifying that matrix into different industries and different sectors as well. Thank you for your time, and see you. Bye-bye.
Thanks very much, Dr. Jamil. Now the speaker will accept any questions from the audience. Any questions? Well, I have a question for you, Doctor. What specific strategies or interventions would you recommend to address the identified areas hindering R&D flow and efficacy? Yes, strategies or interventions would you recommend to address the identified areas hindering R&D flow?
So mainly, Doctor, is what you can't measure, you can't. What you can't measure, you can't manage. The second step of the research is measuring the impact. So right now we identify the most impactful sources of failure demand. Secondly, we're going to be measuring and putting a matrix, an index for measuring those failure demands for different sorts. So once we measure it, we know perfectly what the current situation is, and then we can move on improving it and reducing the impact on the performance of R&D.
Very interesting. Thank you very much, Doctor. Thank you.
Take care. Bye-bye.
Now with the second paper, extensive and enhanced image classification using deep learning techniques, authored by Gousia Habib, Shayma Qureshi, and Shafaq Malik. The paper explores deep learning methods for image classification, proposing a multi-stage CNN model effective on large data sets with features extracted from celestial and lunar data sets. Comparative analysis with existing techniques is presented to highlight the approach efficacy on both small and large data sets. Dr. Gousia?
Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Dr. Gostia. I'm from Jammu and Kashmir, India, and I am postdoctoral fellow in Indian Institute of Technology, New Delhi. So my title of my paper is Feature Extraction and Classification Using Deep Learning. We know that deep learning is revolutionizing every field, whether it is medical, it's satellite imagery, or some other field. Deep learning is very important. So if we talk about the logistics, it can play a vital role in logistics as well. So the contents of my paper are introduction, comparison of various classification techniques, workflow design, steps of image classification, what are the necessary steps that we require for classification of the images, and what is the data set that I am using, what is the proposed methodology, and what are the results I have obtained. So we know that deep learning have many applications. Also in vision, it plays a major role. We have autonomous feature learning using deep learning techniques. We can achieve the data-driven training, and it can also have various applications, or I can say the wide-ranging impact for image classification across various sectors. Already mentioned, whether it can be healthcare, it can be security, it can be autonomous driving, or it plays a vital role in both technological innovation and practical applications. And for logistics, it can also play a vital role, whether it is in defect detection or cost effectiveness or load balancing. It can play a very important role while taking logistics into consideration. So these are some of the basic deep learning techniques that I have compared with each other. Like we have ANN, that's a very basic neural network, followed by SVM, fuzzy logic, and we have also the genetic algorithms that are actually used for optimizing the parameters while we are using deep learning techniques. And what is the workflow design that I have just followed in this paper? That is, the objective was to study various deep learning methods for image classification in computer vision. So what are the data sets used? I have used the benchmark data sets, that is CIFAR 10 and CIFAR 100, and also I have used the celestial and lunar image data sets. We are using the different feature extraction techniques, like I have mentioned few here. SIFT, we have SURF, we have histogram of gradients, and after then I am following the CNN for classification process. After following the CNN with the processing of the images, I am just calculating the results and observing some of the performance metrics across the benchmark data sets that I mentioned, that is CIFAR 10 and CIFAR 100. These are actually the basic steps that we are just following while performing the image classification. That is, we have to gather the data. There must be some data set for training the neural network model. We are just exploring the data, analyzing the data, and after then we are pre-processing the data, such as we are translating it, normalization, and all of the techniques we are applying on this data. After then we have to build the network, and that network should be able to train and generalize very well on that data that we are using, or for the intended task that we want to perform. And after then, it's followed by the hyper-tuning of the model. It is tuning the parameters till our model is fully tuned so that it can learn the intended task that we want to just learn from the data that we are used. Like in this case, I have mentioned that's a CIFAR 10 and CIFAR 100. Finally, we have to deploy the model. But before deploying, we have to take into consideration the several constraints like the computational cost and the other resource constraints. So we have to minimize them, and after then we can deploy those models, whether in edge devices or embedded devices or some other applications. So these are actually the screenshots that I have put here for the data sets that are used for image classification using multi-stage CNN network. So these are outputs that are representing how the features are extracted by using different feature extraction techniques like SIFT, Harris corner detection, and histogram of gradients. These are actually the comparison between the different techniques after feature extraction that I have implemented, like SVM, linear SVM, linear LDA, simple decision tree. So how accuracy is varying across different techniques on the same data set. This is again the performance comparison that is actually comparing 4 algorithms, different basic 4 machine learning algorithms, that is a random forest, KNN, decision tree, and naive Bayes algorithm. And after then we have a deep learning model that plays a vital role in the computer vision, that's the convolution neural network, and it can also be very helpful using in this logistical systems. So convolution neural network is actually the staggered layer, stacking of different types of layers. We have a convolution followed by ReLU. We can have a pooling layer for dimensionality reduction. We can have, again, convolution layer. We can have pooling layer. After then, it's followed by the flattened layer. We have fully connected layer. And finally, we can have the soft max that can be tuned as per our own specific task. So these are some of the results that I have got after training the CNN multi-stage CNN model. These are the training and validation curves. Also the loss curve is followed by the validation curve. And these are some of the comparison results across the different classes on the benchmark data set, that is a CIFAR 10. So how actually the performance is varied across different set of classes. Thank you.
Thank you very much, Doctor. Now the audience, if they have any questions. Any questions for the speaker? No question? Well, it's a really very interesting topic, Doctor, and thank you very much for your speech.
Thank you.
The next paper, an investigation of the healthcare supply chain preparedness, a literature review, authored by Dr. Ashraf Al-Ali, Hussein Abu Rijal, Noor Hidayah Bintu Abu, and Haytham Al-Ali, will be presented by Haytham Al-Ali. In this paper, the authors discuss the impact of supply chain management on healthcare service quality during the COVID-19 pandemic, drawing from literature published between 2015 and 2020. They highlight various determinants, barriers, and recommendations for implementing responsive supply chains to enhance healthcare services, emphasizing the importance of understanding these factors for future preparedness. Dr. Haytham Al-Ali.
Assalamu alaikum. My name is Haytham Al-Ali from Liwa College of Technology. Mic, please. You have mic? Assalamu alaikum. Dr. Haytham Al-Ali speaking from Liwa College. We're going to talk about the logistics or supply chain in healthcare. This general review paper, I will present it on behalf of our student, our PhD student, Ashraf Al-Ali. First, the importance of supply chain preparedness. Not enough we have only supply chain. We need more than supply chain. We need to prepare ourselves, to prepare our companies, to prepare the industry for any changes regarding supply chains. At the beginning, for our students actually, and our colleagues of course, we need to differentiate between supply chains and the logistics. Since the supply chains started from the point of production, okay, the first point of production until the point of consumption. So this is just all steps and chains or processes included. Those 2 points will be considered like supply chain. For logistics, it's only consider the transportation of and shipment of items and these products. From manufacturer to customer, from business to business, and etc. The best example for logistics companies is like Aramex, FedEx, and such companies. So it's important to our students to understand the main differentiation between them. And there's a lot of differences, but this is the main issue. Now, the importance of supply chain preparedness in healthcare, ensuring patient safety. Actually, we need to ensure the patient safety because if we don't have we don't have enough items, enough supplies for hospitals, for healthcare centers, we cannot provide healthcare in good manner. Also in continuous caring. Improving cost efficiency. So if we don't have a good plan for supplying our materials, medically or non-medically materials, we cannot provide them with reasonable prices, actually. Emergency response, just like COVID-19 pandemic and also the cut of supplies routes nowadays, we can just face emergency situation that we need to find some alternatives to cover this shortage. Other challenges, the fragmentation and the cost pressure. Actually, in healthcare sector especially, we have a lot of divisions, a lot of separate healthcare facilities, and when we go forward also we have sub-specialties, sub-healthcare sections. We have managed care, we have critical care, we have ambulatory care, so we have different types of cares, and with those different types of care we can get another categories from them. So we need to cover all of these categories and services with their own supplies. Demand and the product complexity. Actually, the demand is very high for healthcare supplies, and we need to cover. And product complexity, the production itself is very hard. If you remember during the pandemic, the COVID-19 pandemic, some countries cut the transition of some health products, and they take that healthcare materials. The gap in such study is the preparedness itself, the readiness. There's limited research regarding supply chain readiness in healthcare. We need to bridge this gap by studying this literature and find some solutions. Actually, not only studying, we need to suggest alternatives to that, to such risks. Improving practices according to the available solutions, of course. In this study, the researchers surveyed like 610 articles. Then we summarized only 7 papers, which is very limited articles. Problem with such methodology is very short time we have, very short period, like 5 years only, and very limited number of articles, actually, according to many reviews conducted to this paper, so we shorted the number of articles to 7. What we need for future research, longitudinal approach, which is already conducted by the student, but for this article, we need to do longitudinal approach for cover more time and research. This content, we conduct content analysis, summarizing the methodology, the results of this research. We will discuss many approaches of this content. First, the strategic approach and partnerships. We need to think strategically for supply chain, not like logistics. Logistics is short term. Supply chain, we need to plan for future, for many years at least, okay? So we have here like need to invest in technology, in artificial intelligence, innovation ideas also, especially in what we faced in COVID-19, just raise the awareness regarding the innovation that we need. Public and private sectors partnerships. We need to create partnerships, relationship between all parties, even public or private. And sometimes we need a partnership between countries. Flexible solutions, we can just find the flexible solutions like what we faced during COVID-19. For example, the back-to-back transition and other collaborative solutions. Co-designed solution, supply chain and health sector is very complex, not like other sectors. And the competition is very high and there is a very limited sources to get that supplies from. As we said in the panel discussion even, we have risks already addressed. We have many risks in this regard, but we need to just check what solutions that we can provide. Supplier relationship, we need to maintain that relationship between the hospitals, the healthcare sector in general, with their suppliers. And inventory management, we need to manage our storage actually. This storage needs to be maintained not at the last minute. Actually, the majority of organizations or hospitals, they think at the last minute thinking. We take action when the crisis has happened. This is a problem. Okay, no, we need to manage our inventory. We need to have some alarm, some checkpoints that call you to supply your storage, your inventory. And also this inventory need to be filled automatically. That means we can create a contract, automatic contracts between the hospitals, the healthcare sector in general, and the provider and supplier. Transportation, we talk about a creation of contingency plans and alternative routes. You know that nowadays we have a problem with transportation actually routes, and there is a cut of these routes, and we need alternatives. Always we need to plan. We have actually an alternative plans and a risk management plan for supply chains. Fluctuation is demand in the demand. Actually, the demand in medical and non-medical supplies is changing based on the population, based on the political issues, based on the environment, business environment, even the population, and also the public health situation actually. So sometimes we have high demand, sometimes we don't have that high demand and regular demand. We need to conduct forecasting studies by conduct analysis for historical data. Now we talk about the big data era. We have a big data era. So when we talk about big data, we can just take a benefit from that data and make some forecasting, okay, for the patterns that we have in supply chain. Regulatory compliance, actually, we talk about the important part, actually, of the government. Government is one of the most important part of the supply chains. Supply chain is not about supplier and customer only. There's somebody in between should govern the relationship between the supplier and the customer. Create rules, responsibilities. Okay, there's some responsibility should be handled here. Also, technology integration and artificial intelligence and whatever that we have, financial stability. We cannot just open hospitals, for example, without check the liability of that hospitals and healthcare institution. Disaster recovery, implement the risk. We should have a risk plan and the alternatives and managing that such risk. As we said, government influence is very important. We need to sustain the medication and medical and non-medical material supplies. So who can guarantee this relationship and supplies? Actually, in direct way or indirect way, the government will be in the front, actually. So in that way, we need to involve the government in every solution that we have and every risk that can be faced also. So the service is included the government, the suppliers, and the customer, all actors. Recommendations. Those recommendations based from experience and also from some literature. Support vulnerable groups. We have a specific kind of people, a specific kind of patient, health risk, illness. Okay, we need to categorize those groups and make prioritization. There's no type of patient not important, all important. Now I need to prioritize the assistant and the supplies for them. Provide technical assistance, also assistant input services, stability, resilience, building, improve the efficiency of healthcare logistics. Like we talk about the automation of logistics, automation transition and such things. Supporting the local economy. Instead of importing medical supplies, why we cannot just invest in national economy, okay, to create such manufacturers and industries and make this, we can export such supplies. Support local economy and make informed decision, sometimes exporting or importing or supplying decision based on what's X or Y opinion and these things. No, we need to create that decisions based on the data, since we have a big data era already. Investigate logistic market also. We need to prioritize and also to make the logistic lists. Address supply chain disruptions, also recognizing the role of government, enact transit agreements also. These agreements should be renewed automatically and based on the inventory shortage. Apply innovation methods, also like back-to-back leads during lockdown, and mechanism equipment for automation. Enforce compliance and define the clear responsibility for every party. Leverage supplier relationships and improve inventory management. Develop transportation contingency plans. Implement also flexible procurement methods and facilitate collaborative solutions, especially investing in technology and artificial intelligence tools. Thank you for listening, and question, please.
Thank you very much, Doctor. And now, any questions from the audience? No questions? Well, thank you very much, Doctor. It was really interesting speech. Yes.
لا لا عادي بتكلم. ايوه بس
Thank you very much, Doctor. And I want to ask you about, please, can you illustrate which criteria that you select, that you use to select or to filter the papers from literature review? I think you collect many of papers, and I think you use the systematic literature review, and the systematic literature review has a protocol about which criteria that be used. Thank you.
Thank you very much. Actually, we plan to use systematic literature review, but we just make it as a narrative review, not a systematic literature review, because we're gonna throw a lot of phases and the appraisal of articles and the process and be reviewed and another review, the longer process. This is only a narrative literature review. Thank you.
But I think if you enhance your paper,
of course,
because you collect many papers, I think 500 or more than that.
Yes.
So that this is nearly to systematic literature review.
Yes.
And I think you need to enhance this paper. This is a good work.
Thank you very much. Thank you for your comment. Actually, we are in the process of, this is a part of the thesis of my students, so it's already in the process. Thank you very much. Thank you.
Thank you very much, Doctor. Data fusion of heterogeneous data sources for intelligent transportation systems is the next paper authored by Dr. Tariq al-Sahafi, Dr. Ali al-Ammari, Prof. Ramiz al-Masri, Dr. Badr al-Shamamri, Dr. Musa al-Mutayri, and Dr. Umar Abu al-Ula. The paper explores data fusion techniques for intelligent transportation systems, ITS, leveraging big data to improve accuracy and extract knowledge. It introduces methods for integrating heterogeneous data sources, preparing them for deep learning, and presents applications including traffic data set analysis and traffic flow forecasting to demonstrate the efficacy of deep learning with enhanced features. Dr. Tariq al-Sahafi.
Assalamu alaikum wa rahmatullahi wa barakatuh. Asad Allah masaakum bi kulli khair. Today I'm presenting our paper, Data Fusion of Heterogeneous Data Source for Intelligent Transportation System. The introduction, the intelligent transportation system play a critical role in our life, such as in enhancing the road safety, minimizing the time for the traffic, and reducing the traffic accidents. However, in order to get accurate information, we have to involve several factors, since the road status affected by driver behaviors, external factors such as weather, social events, and other events. So luckily these days, we have a big data from different sectors, data from government, data from specific agencies, such as the road network sensors that count the number of cars, or weather station incidents reports. So any ITS application will require the data fusion in order to get to provide a better result. So in this work, we aim to gather and pre-process a huge amount of traffic information, weather information, social events, and temporal information, road network, in order to provide a data fusion techniques for ITS application. As a result, for our framework, we provide two applications. The first one is the data analysis and visualization. And in this one, the end user will be able to analyze the road status, the traffic accidents. Also, we apply the traffic flow forecast using a deep learning technique, since the deep learning have shown a better result when we use an external feature in traffic flow forecasting. So in the related work, data fusion in general, the goal is to combine data from several sources, and the result is to provide a better estimation for a specific situation. Let's say we have a traffic accident, a specific part of the road each week or in the morning. So we need to collect several data sources in order to understand the specific situation. So in the ITS, there are several works have been provide a better result when we enhance it with external features beside the feature from the traffic information. And this is some of the work. So motivated by these papers where the extra features and using the deep learning provide a better result, we apply several data fusion techniques in order to come up with a data set that in a uniform way for the deep learning or for the data analysis. So the data set that we use, it has the traffic information that collected by the California Transportation, where they have a loop on the road that has the number of cars each 5 minutes. Also, we have the traffic incidents and the traffic jam on a specific road. The external data source beside the traffic information is the weather data, the temporal data, and the point of interest around the road. So this is just a description for the data set. We can see here on the left is each sensor provides the data each 5 minutes, the number of cars passed by a specific sensor, and we can have the speed, occupancy, and the flow. We can see in the figure, the flow is the blue one. Once the flow increases, the speed is decreased. That means we have a large number of cars at that specific sensor. Other data set is the traffic jam. We can see this one example, the traffic jam start point and the end point for the traffic jam, and we have the time for that traffic jam. We have also collected the point of interest around the road. As we can see, if we have a school at the time when they get in the school or out of the school, we have a traffic around this area. So now we describe the model or the framework to fuse all these data together. We start by having the traffic flow sensors. Around that sensor, we collect all the possible data in a specific sensor. We merge the traffic jams, the traffic incidents, the weather data, temporal, all this data for each sensor on the road. As the output of the techniques that we use, we provide two data sets, one for analysis and the other one for the traffic flow prediction. These just details how we can fuse. As we can see in the image, all these data are sensors on the highways in LA, for example. So each dot means a sensor that collects the number of cars each 5 minutes passed by that sensor. We did some filtration in order to extract, since the number of sensors is very large, we create a grid, and then we pick a sensor in each grid, and we keep that sensor. As output, we come up with the sensor ID, the flow, and the speed, and the average occupancy at that sensor. And the one in the top is the number of records after the pre-processing. Now we come up with data fusions for the traffic accidents. So we have a sensor on the road. The traffic incidents and the sensor information are not related. So we want to find a method to merge the traffic incidents to the nearest traffic sensors. These are the algorithms in detail in the paper. We start with the semantic matching. Since we have the number for the highway and the direction for each accident, in the sensor we have the number of the highway and the direction. We start with the semantic matching. Then we do the spatial matching by matching the accident to the nearest sensor. Since each sensor will provide us with the traffic flow, if there is a specific accident near to any sensor, it will affect the traffic at that sensor. Then we do the temporal matching since the sensor provides the data set for each 5 minutes, so we do the temporal matching by by round up the time for each accident to the 5 minutes. In the example down, we can see at this sensor, we have the flow occupancy, and we have several accidents at that sensor in this 5 minutes. And this, the star is the sensors, and the below that is the accident around that sensor. And we do this for all the accidents. Then we merge the traffic jam for each sensor. If it has a traffic jam, we add the traffic jam information. For example, in this image, we can see all these sensors will have the traffic jam information, such as the length for the traffic jam, the severity of the traffic jam. And these the features. Also, for each sensor, we collect the weather data from the website called Dark Sky API. We just need to provide the latitude and the longitude. Then we collect the weather information for each sensors. This is the summary of the traffic data set after applying the framework for the data fusion. For each one, we have the traffic information, we have the temporal and the weather, and the information about each incident or traffic accident, then the traffic jam and the point of interest around each sensor. This is just one example of one record at 5 minutes. We have all the features, if it has an accident or not. So the output of the traffic data fusion, the data set, we apply it on two applications. The first one is the data set analysis and visualization. We use the framework that we publish in other paper as a data cube. So we have a temporal analysis, spatial analysis, spatial temporal analysis, and the user can ask a question: what is the most freeway with the most accidents? Or what is the traffic status at freeway 5 in the morning, and so on. So the user can have several analyses. Also, we provide a GIS map on these accidents. The one on the left, these all the accidents in the 6 a.m. in the 6 months that we collect the data. And the one on the right, it has the traffic jam for a specific time. Next, we apply the deep learning algorithms for traffic flow prediction. So the traffic flow forecasting estimate the number of vehicles on the road for a different time interval. Let's say now the time is 12. I want to know what's the number of cars for the next hour. And this will affect the flow control system, route planning, and navigation system. So in this traffic flow, there are several factors, such as the spatial dependency on the different direct node, multiple temporal dependency. The traffic in the morning is different than in the evening or in the afternoon. Other factors or social events. So our goal in this paper is to check if the external features will enhance the deep learning approach or not. So we apply 3 deep learning algorithms. They are somehow similar: the LSTM, the GRU, and the bidirectional LSTM. This is the experimental setting. We use 2 months for the training and the validation and the training testing sets. We train each sensor individually in the network, and all the model implemented using Keras. We model to train each sensor individually. And we use a historical average as a baseline, and each of the deep learning algorithm with the traffic features and with the external features. And we use the mean absolute error as evaluation metric and the root mean square errors. And this is the result. As we can see, the historical average only used the last hour to predict the next hour. For the deep learning, if we use the traffic features, for example, in the LSTM, the mean absolute error was 47. When we add all the external features, and we can see the error is reduced according to our experiments, the bidirectional LSTM provide the better result when we use the external features beside the traffic features. This is just as example of visualization. For example, this the past hour, and then each models the result after the next hour. This is another example if we want to predict from 4 to 5 p.m. and we use from 3 to 4 as a training. As we can see, the bidirectional almost provide a better result compared to other algorithms. Just a long image where we show the historical average, the bidirectional LSTM, which provide the better result and the actual value. So in our experiment, we train each sensor individually, and we can improve the results, such as we consider the spatial correlation by using the graph and neural network, for example, or we design a hyper deep learning model with several pipelines to learn different traffic patterns. So in conclusion, we provide a data fusion for any traffic, for any intelligent transport, for any ITS with several techniques. We integrate and extract feature from multiple data sources to be ready for a deep learning algorithm. We generate a pre-processed real-world traffic data set that made publicly available. Also, we provide as 2 applications on the output of the data fusion techniques that are traffic data analysis and traffic flow forecasting using deep learning. Thank you so much for listening.
Thank you, Doctor. Is there any question from the audience?
Okay, great presentation, nice work. I'm going to ask, how is it easy for you to reach traffic data in Jeddah and to do these analysis in Jeddah traffic?
It's really great questions. I have been trying for the last 4 months. I did not find any data yet. So hopefully we'll find, inshallah. But outside for California, I have access to all the accident until yesterday. But here in Jeddah, I have tried many times. Until today, I did not get any data set. Inshallah, we'll find one day.
Good luck. Thank you.
Inshallah.
Thank you very much, Doctor.
يعطيكم العافية. السلام عليكم.
Thank you. The Hajj in Mecca involves transporting millions of pilgrims between holy sites, with the shuttle buses being the busiest mode of transportation. This paper introduces a framework utilizing the NSGA3 optimization algorithm to select transportation companies based on cost and service quality, outperforming heuristic algorithms like best fit and first fit. This paper will be presented by Dr. Mohammed Al-Touhi.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. I'm pleased to present our research work towards optimizing the logistic transportation selection in Hajj. This research has been done by my colleagues Dr. Marwa Fikri and Dr. Samiha and myself, Muhammad Musalih Al-Touhi, University of Jeddah. So this is the agenda. We'll give an introduction about the problem, then we describe the problem and the logistic transportation companies, and then give the experimental work and conclusion. Introduction, as all of us we know, in Hajj, there's a million of people are need to transport from one place to another place. So our aim of this work is to find an optimization algorithm that able to find the best solution, the best company that able to transfer the Hajj from one place to another using the minimum cost and maximizing the quality. So this is the problem definition. As we mentioned, that to management the complex problem of transporting million of Hajj from one place, from Mina, for example, to Haram and back again, and from Arafat and so on. So this is very huge problems that need too much computational to calculate and to find the optimal solution, the best company that able to transfer those Hajj. So our aim to use the logistic transportation company selection, this to select the best transportation companies. We use this model. The Ministry of Hajj asked for the company the agent to apply for their own plan, and this filter is used to remove the companies that not qualified to pass the processing. And our aim to find an optimizer that able to find the best solution to maximize the quality service for the Hajj and to minimize the cost. So this is the mathematical model for the problem is to minimize the cost and maximize the quality. So this is the data set generated. We generate a randomly data set for 600 transportation means companies, and these companies divided into 3 categories: the small, medium, and large category. Each category we use the cost and the quality service. Then we use the maximum for Hajj for 10,000. This is our obtained results. We apply the data. We use the cost, created the data randomly. We use, as we mentioned, 3 categories: the large and medium and the small companies. The large, we suppose the cost is between $50 to $60, while the quality is between 90 to 97%. While the medium companies, the cost is between $40 to $50, while the quality is between 85 to 90%, while the capacity is 500, whereas the small companies is random, using the cost between 30 until 40, while the quality is between 80 to 85%. Using the capacity of the company is 250. Then we apply our proposed method using genetic algorithm. We compare the genetic algorithm against best fit and first fit. We find that genetic algorithm was able to find the best companies, best set of companies with low cost and high quality service. And this is the conclusion. As we mentioned, that the aim of this work is to find the best companies that are able to transfer the belgium from one side to another side. And as we mentioned, this data was created randomly, and we find that genetic algorithms are able to outperform other heuristic algorithms such as best fit and first fit. Thank you.
Thank you very much, Doctor. Now the speaker will accept questions from the audience. Yes, 1 second.
Thank you, Doctor, about your effort. And maybe I didn't hear you clearly. So I want to ask you about which features or characters or impact indicators that consist of costs and quality. How to measure about your input of the model. You focus on cost and quality. What is the factor of cost and quality?
Okay. Generally, as we use two factors. We want to minimize the cost and maximize the quality. In terms of the cost,
I ask about the cost as a factor. Consists of what?
In our case, we use the cost as in terms
absolutely,
of...
Absolutely. Your input of model.
Yes.
Cost as a total number?
Yes, total number. As I mentioned, it is 3 categories of company. One between 50 to 60.
And the quality, the total number?
Yes, exactly.
You take them as a given.
As exactly a column, yes.
But I think many of factors,
exactly.
Cost and the quality, this is a challenge how to measure them. This is more challenges for the input of your model.
Yes, I'm
so
agree.
That I think
yes.
you need to study how much measure the cost and how much measure the quality.
I'm totally agree with you. Yes, but in our case, the case that we don't have the actual data. That's why we created random data. That's why we just use the cost as one column, as a whole set, and the quality as well. Yes, okay. The main objective of this work, we just to define the companies that able to give the high quality with the lowest cost. We didn't go inside the
perspective. Quality of many perspective. Yes. There's many partners in the Hajj routine. If you want to measure the quality, there are many of perspective about that. Thank you very much.
I'm totally agree with you. Yes, thank you.
Thank you very much, Doctor. Thank you. Now we will stop for a 30-minute break, and we'll be back, inshallah, at 1 p.m. sharp. Thank you very much. Everyone, and welcome back. The next paper, titled How Supply Chain Resilience Supports Firm Performance in Face of Disruption, is presented by Fahad Al-Farsi. This study investigates the relationship between supply chain resilience and firm performance during disruptions, emphasizing the need for exploration of the time of disruption occurrence. Through in-depth interviews with UK manufacturing sector informants, it shows the impact of supply chain disruptions on operational and reputational performance, offering managerial suggestions for safeguarding both aspects. Dr. Fahad?
السلام عليكم ورحمة الله وبركاته. أسعد الله مساكم بكل خير. Hello everyone, my name is Dr. Fahad Al-Farsi. I'm very pleased to present my research topic, which is about how supply chain resilience support firm performance in face of disruptions. I hope this topic relates to most of you and you find it interesting. I think before we start, we need to agree on that we are living in uncertainty era, and it's really hard to manage based on forecasting only. That's why the topic of resilience is getting very interesting to both the academics and practitioners. In this presentation, I will try to start with giving some background and introduction about the research terms, and then we will try also to provide a better understanding about resilience, because as I can guess, not most of the audience will know what resilience means. Then we will talk about the research context and the research questions, and then we will discuss what the methodology that we use to answer our research question, and then we will deliver or will highlight the key finding and result and end up with the conclusion. What makes resilience as an interesting topic, because as I started, most of supply chain become very vulnerable and disruptions becoming very severe and very significant. And also the frequency of this disruption is increasing. As you can see from the figure, just between 2019 and 2021, there is a significant rise in supply chain disruption numbers. This normally disruption resulted in production delays, increased operational cost, loss of revenue for companies and customer satisfaction, and also might threaten firm reputation and threaten its existence. 94% of Fortune 1000 companies had experienced supply chain disruption, and 78% of manufacturing believe that COVID-19 has a very significant negative impact on their financial performance. And also about 40 to 60% of small business, when they encounter a disruption, they never reopen after that. And also, when we look about the impact, we found out just only one type of disruption, which is natural disaster, alone it cost about $306 billion in 2017, almost more than double of the one in 2016. We might question what makes this disruption is very significant, why it's increasing in numbers. We agree that some of the causes are external to supply chain, caused by natural disasters, and some of them caused by geopolitical issues. But in fact, it's caused also by some of supply chain practices like just-in-time, cross-docking operation, single sourcing, outsourcing, offshoring. All of these practices could lead to reduced cost and improve the company operational performance, but unfortunately make companies very vulnerable to supply chain disruption. That's why we found out what differentiates companies that can cope with disruption, those who have the capability of supply chain resilience. In fact, resilience, when it comes to supply chain literature, it is a new topic, but it started a long time ago in engineering and material science to describe the material ability to bounce back very fast. Also, this definition was adopted by most of researchers in the beginning of 2000s, but later on, they differentiate passive resilience from active resilience. Active resilience always have a kind of a decision making because it's guided by human beings. That's why they adopted the social and ecological definition, which understand resilience as a supply chain capability to prepare, not only to recover. And also when they recover, not recovering back to the normal state, it's recovering to a better state to not being disrupted by the same disruption. A lot of research has been conducted to find out how supply chain resilience is built. A lot of capabilities have been proposed. Among them, flexibility, feasibility, velocity, redundancy, collaboration are the most cited one. That's why in this figure, we understand resilience not only as a kind of the material definition, it's not only bouncing back, it is about resisting and adjusting to disruption. And when they recover to a better state. Resilience also, resilience when it is defined, it's defined based on the kind of, we call it zone of balanced resilience. We are increasing resilience, we're building resilience by matching capabilities with vulnerability. Where the best of resilience, it is when it is in the balance zone. Why? Because building this capability is not free of charge. It costs the company. That's why company should increase the capability when some of the link of supply chain links are very vulnerable, and not to invest on those links which is less vulnerable. If they do the otherwise they will lead up. If the capabilities are increased and the vulnerability is not high, that will lead to erosion of profit. On the other hand, increasing vulnerability while the capability are very low, this is going to make the supply chain very vulnerable and exposed to risk. A lot of research, as I said, have been conducted to understand how supply chain resilience can be built. But unfortunately, very few research has related resilience to performance, because as we said, resilience is not free, it has a cost. That's why we need to examine its value based on cost and benefit analysis. In this research, we are arguing that to understand the value of supply chain resilience, we need to examine its influence on the moment of supply chain disruption, to know how these companies benefiting from acquiring these capabilities. That's why we are trying to answer two questions. How do supply chain disruption impact firm performance, considering different characteristics of disruption, severity, type, period, frequency, and also responsibility. And then we will try to answer that second question, which is how resilience or supply chain resilience help firms in containing disruption impact, considering these disruption characteristics. I put here a slide because I think it's really important to differentiate resilience with very related terms. One of them is robustness, the other agility, and the third one risk management. Those another term that's used in the literature which has a different meaning. Robustness is about withstanding, it's not about adjusting. Agility, it has a kind of responding, but that kind of responding is really focused on the demand side, try to cope with the demand change. Risk management, on the other hand, is focusing most on, because it's a quantitative approach, on risk identification. What resilience relates to is most of those disruptions which is rarely happen and having a huge impact. That's why in our methodology, we found out that a qualitative approach, we think it's the best approach to allow us to answer the question that has a type of why and how. And the data were collected from experts, 17 interviews with expert representatives from UK manufacturing. And the data were analyzed using thematic analysis, also following Myers and Hemperman recommendation on the 3 steps: data reduction, data display, and data conclusion, and to check the data or the result quality, we conducted the reliability test, and we collaborate with 2 independent researchers to assess our coding, and we reached to a 0.89 reliability, which is above the threshold 0.7. And here some characteristics of our interviews. As it says, they are all from manufacturing by industry, but they are coming from different product type. All of them, they have a great experience to answer our interviews questions. The key findings that we found, that our research provided, which is really interesting because when we relate to the literature, the most dangerous disruption that firm may face come from avoidable and frequent incident. We said similar incident, because most of the firm, they manage disruption based on the impact and the probability. But in our result, and we will elaborate more on this, the firm is held more responsible, and the customer gets very angry if the company disrupted by the similar disruption and could have to do something to avoid it. It has an internal control. Here we quote the words of some of the managers. One of them say, we may have a very good record all year, but if we have a bad one that we can do something. He's talking about avoidable incident. But we haven't. He is referring to customer, get annoyed very quickly, and our business will be in danger. Here he's talking about the internal control. The other thing, he's talking about similar disruption. Another manager says these things can lead to a problem and to a bad reputation. The extent of the impact really depends on how often similar disruption are happening. Also, to answer the other research question, which is about supply chain resilience, we found out supply chain resilience has a significant role in containing both operational and reputational damage, and also we found out that flexibility, visibility, velocity, redundancy are those capabilities which making resilience and impacting the operational impact. But very interestingly, learning, which is rarely mentioned in the literature as an element of resilience, it is the one that can help firm to cope with a reputational damage. Why? Because learning allows supply chain to learn from the past incident and prevent the occurrence of similar disruption. Here, as an figure, sorry to, yeah, 1 minute. We found out, to answer our question, we found disruption which has this kind of characteristics, infrequent incident and unavoidable incident, only impacting operational damage, because here the company is not held responsible for the incident. On the other hand, frequent incident and avoidable incident are really harming the reputational damage, which is more risky because the company here is held responsible. When it comes to the capability of resilience, or the element, we found flexibility, visibility, redundancy, velocity is helping to contain the operational damage because it helps firms to recover very quickly. But about learning as another element of resilience, it allows firms to avoid being disrupted by avoidable incident and also to avoid being disrupted by similar incidents. I'm very sorry, long time. Thank you very much.
Thank you very much, Doctor. Now the speaker will accept questions from the audience. Yes, Doctor.
Thank you, Dr. Fahd. It's a great work. And when present the slide about the quality approach, about the methodology you used in the paper, I believe if you used system dynamics to illustrate it, to illustrate the model, to illustrate the impact of supply chain resilience on all factors of our organization. I think this is a need to enhance your paper about this approach, because you didn't use quantitative approach, but you used qualitative approach. And I think if you used qualitative approach, maybe you need to illustrate what the impact of all elements of the model, each others. I think this need to be that. Thank you.
Thank you very much, Doctor. Thank you for the suggestion. I think it's a good point, and this research is just a part of a big research. And what you are suggesting, it is considered in another methodology and another analysis, but this is just talking as a part of the big research.
Thank you very much, Doctor. Thank you. Developing a VRP-based GIS model for passengers quarantine accommodation is the next paper authored by Mohammed Shboul, Ammar Al-Bazi, Maria Sacco, Shahd Al-Aid, Farah Nasruddin. In their paper, they address COVID-19 impacts on travel, proposing a VRP-based GIS optimization model for efficient passenger allocation in hotels, minimizing waiting time at borders and increasing hotel utilization. By utilizing VRP methodology and conducting parameter variation experiments, the study offers efficient strategies for optimal passenger allocation, considering factors like hotel distances, passenger numbers, and bed capacity. Dr. Mohammed Shboul.
Thank you very much. Assalamu alaikum. Thank you for attending, and I would like to thank University of Jeddah for organizing this conference. It's a really good one, and hopefully it will continue. My topic is developing a VRP-based GIS model for passengers quarantine accommodation. VRP stands for Vehicle Routing Problem, which is a logistics problem dealing with multi-vehicles, multi-routing problem. I will talk about the background of the problem and then the problem statement. Then the model development, including the model agents, the passenger flow diagram, and then the bus movement state chart, which is an agent-based technique, and then the passenger allocation and the transportation flow chart, and then the case study results and analysis and discussions. So we all know the COVID-19 pandemic has really affected all the world and put on our shoulders a lot of pressure. So the restrictions on the traveling between the countries has been high, and we have to deal with it to cut the spread of the disease. Okay, so people quarantine has been addressed an effective mode of controlling the spread. One of the ways to control the spread. So border authorities effectively manage the quarantine process of incoming passengers. This is one of the methods that many countries have dealt with to control the spread. So we dealt with that problem using the VRP-based problem. So the people must be transported via dedicated buses, which is thing that we in Jordan did. So people who were willing to enter the country during the lockdown or the let's say the curfews, they had to be quarantined for 14 days. And which is the incubation period for the disease itself or the virus itself, and they had to be accommodated in hotels and specific places. So during the accommodation process, many restrictions are encountered when performing the transportation process. Like family members, they need to stay together. As you know, when they are traveling to the country, they need to stay together, otherwise it's not. There is no point, especially that if any one of them is infected, he will infect the rest of the family members. So it doesn't matter if they are staying together or not. The direct contact between the passengers themselves and the people who are dealing with the quarantine process should be avoided. The number of available passes and the capacity, those are the constraints or the factors that we have to deal with and consider when solving this problem. The number of available hotels and room sizes, which makes sense because it's a capacity problem, is one of the constraints. And then the bus routing itself, which means because there are some routes has capacity for transportation, so we need to consider that, and also other factors which is not mentioned in this list. So the purpose is to help the authorities actually to effectively manage the quarantine process. They need to know how much buses, which family should be assigned to which bus, to which hotel, to which room, and how many rooms do we need. All of that stuff is to help the authorities to actually do the accommodation process. Even though this is a COVID-19, or it seems to be a disease or a crisis problem, it's what is applicable for this problem is applicable for all other logistics problem, including but not limited to the transportation, the logistics of the goods itself, maybe military also stuff. So it's applicable for all other logistics problems. So we want to enable the best quarantine allocation plans. It's an allocation also, considering the passenger social requirements and resource capacity. So this is the problem. We have a capacity problems and we have a social requirements which we need to consider when solving this problem. Strategical planning for the scheduled arrivals also, you need to help authorities to schedule the arrivals of the airplanes and the incoming passengers. You need to schedule those to avoid congested families or congested hotels with the passengers who should be quarantined. Okay, so let's move to the methodology. The methodology is basically using what we call the Geographical Information System. It's a GIS, which means we need to consider an online problem synchronization or synchronized with the VRP problem itself. So on the map, okay, or using the GIS system, the Geographical Information System, we solve the vehicle routing problem considering all of the factors I've just mentioned. And objectives to for solving this problem is actually to minimize the time or the waiting time on borders, which is a very crucial factor, and then increase the hotel utilization. We need to increase the hotel utilization. We need to avoid the contact. Also, we need to minimize the waiting in the airport itself, which is a sensitive factor. So the VRP-based GIS model, first I will talk about the model's agents. It's a little bit, maybe it's a new concept, but it's one of the simulation methods rather than the discrete event simulation. We all know about the discrete event simulation and the system dynamics and the agent simulation or agent-based simulation. And then the passengers flow diagram, then the bus movement state chart, and then the passengers allocation and transportation flow chart, which has been done during this problem. So for the agents, we have 6 agents and their attributes. For the agent simulation, to do the simulation, you need to define the agents and the attributes of each agent, okay? First, we have the passengers. We consider the passenger as an agent, and then the hotel as an agent, the truck, airport, beds, and rooms themselves. And every one of those has its own attributes. Now, agents are active and interactive. It's different than the discrete event simulation. If you are familiar with the simulation method, the discrete event simulation, you do the simulation or the modeling up down the hierarchy or up down the model, but rather in the agent-based simulation, we do it from bottom to up, which means we define the agent first, we define the attributes and the way they interact with each other, and they develop the model this way. Okay? Okay, for the passengers flow diagram, the passengers actually arriving at the airport, they need to be quarantined for 14 days, which is one of the constraints I've just talked about. And then they are allocated in those hotels. This is the flow of the whole process, starting with the arrival, ending with the end of the incubation period, which is 14 days, which means if you are already infected, you will be done by the end of the date. So this is the state chart. The state chart is a little bit, maybe it's not a flow chart, it's a state chart which defines the state of each agent and what happens if what happens. So if a specific activity or a specific event happens, then this triggers the other procedure or the other states to be initiated, and the message conveyed between each state and the other state is conducted or executed. Okay, and this is the code that accompanies this state chart. You have to do a Java coding to be able to understand this state chart, or to build it, I mean. And then the passengers allocation and transportation a flow chart. Actually, the passengers arrive at the airport, and then the whole process starts. And all we know what happened else, we need to assign them to the buses, and then the buses goes to the hotels, and then they have to be incubated. All this stuff, and if it's the loading or unloading problem, which is one of the, let's say, pen backing problem, maybe the one that Dr. Mohammed have just talked about. Okay. So the case study we've conducted this case study in Jordan, starting with the Queen Ali International Airport, which is the main airport in Jordan, and then we did an online GIS map using the AnyLogic software. It's a big software using to do all kinds of simulation, including the agent-based simulation, in addition to the discrete event and the system dynamics, as I've just said. Okay, so we assume that we have a rate of 10 trips per day. 10 trips, and each trip has like 35 to 50 families. This is the input data, okay, and they will be created randomly. We've just made those assumptions based on our knowledge of the airport, and the family size is actually determined to be between 1 and 3. All are uniformly distributed, and all of these are assumptions based on some kind of knowledge about the process that we are talking about. Now, after families arrive at the airport, the loading process will start, and the state chart that I've just mentioned will be started. Now, this is the input data for 35 hotels that we've managed to secure information for, including the name of the hotel, even though this might be a little bit security purpose, but this is the data. It's fine to see it. The capacity of each hotel and the exact location X and Y on that GIS map. Okay. So we use those on the Google Map, which is integrated with the AnyLogic software that I've just talked about. This is how it works. So you exactly indicate the location or the exact location of the hotel itself on the map, on the GIS map, and then you start the simulation. This is interactive map. Okay. So as I said, the GIS or the AnyLogic was used. The AnyLogic software has the ability to configure and retrieve agents on the current map location online and synchronize all of these state charts together. Move the agent along the pre-existing routes, which should be indicated based on the last updated Google map, which is integrated with the software. Okay?
Doctor, one more minute, please.
1 minute?
Yes,
okay, sorry. So this simulation was done for the period from May 1st to May 8th in 2020 for 1 week, and this is the flow chart or the flow logic integrated with this model. Then the performance measure that we are looking for, which is the number of buses versus the time or the waiting time spent in the airport, which shows that the waiting time has decreased considering all of our factors that we talked about. So the agent-based GIS model was presented with the solving with the VRP, which is, as we said, the vehicle routing problem rather than the traveling salesman problem, which deals with one agent or one entity, but with the vehicle routing problem, you have multi-routes you have to solve for multi-purposes. Okay, the agent-based modeling approach was used to model the interaction, okay, between all these 6 agents that I talked about. The final conclusion is that we cannot have more than 47 planes with 120 passengers on them, on each of them, okay, to be accommodated in those 34 hotels. This is just a case study to be conducted and maybe implemented in other similar or lookalike problems in logistics, including the crisis that might happen and what you need to do with the goods or the transportation itself. Especially, we are talking about the future of the logistics. Okay, and for the future work, we might consider other factors like food and medical, care resource allocation, maybe different capacities, or maybe different factors like the uncertainty of other factors that might be considered to deal with this problem could be as a future work. So I guess that's it. Thank you for listening. And again, thank you for the University of Jeddah. Thank you.
Thank you very much, Doctor. Thank you. The doctor will accept questions from the audience. No questions? Okay.
Thank you, Doctor. This your paper and your work alignment with Hajj season also. This is the same problem about the movement of in the Hajj seasons. And I think in one of the slides, you talk about the purpose of this model to effectively management. No, not to effectively, to efficiently. If you want to minimize the waiting time for passengers, you aim to efficiently, not effectiveness. To take the achieve goals with minimize cost. And this a good work, and I think it's very important for Hajj season also. Thank you very much.
Spot on comment is efficient, and thank you very much. Thank you.
Thank you very much, Doctor. Next is performance investigation of light car assisted by solar panels, a paper presented by Boubacar Dukkar. In his work, he designs a hybrid solar vehicle with a parallel hybrid system featuring an internal combustion engine and an electric motor. MATLAB simulations show fuel consumption reduction when the electric motor operates at full power. Dr. Boubacar.
Bismillah ar-Rahman ar-Rahim. My presentation is under title Lightweight Car Powered by Solar Energy from the University of Wargla, Algeria. I repeat. Bismillah ar-Rahman ar-Rahim. My presentation is under title Lightweight Car Powered by Solar Energy. I am from the University of Wargla in the south of Algeria. It's the same climate like Jeddah. So this kind of car can be a solution for Yes, we start with the content, the energy context, conventional vehicle, hybrid electrical vehicle, problematic description of the PV system, application of PV system on HSV, it means hybrid solar vehicle, result and discussion, and the conclusion. I have problem. Yes, we start with the energy context. We start with the energy context. For the fossil fuel, we have the problem of pollution in the industry and mainly in the car. Also, we have a high consumption of this fuel, fossil fuel, so it should be finished in certain limited time. So all these effects of this energy, of fossil energy, we have different effects like inundation, shortage, the melting of the glass. So we need to use renewable energy. We have different kinds of renewable energy: wind energy, solar energy, hydraulic energy. But this energy is intermittent, so we need storage. For the storage, we have different kinds of storage: heat and pressure, hydrogen, and electric or battery in the form of electric. For each one, we have the use of turbine or gas turbine, also use of hydrogen for the fuel cells for hydrogen, and for electric or battery, we use this battery in electrical vehicle like that, which Algeria start to fabricate this kind of energy. It's a Fiat 500. Here we present the different kind of present the conventional vehicle, which it is based on the fuel. It may be gasoline and bioethanol, biogas, and hydrogen. But for the second kind, we have diesel or biodiesel, which is based on the combustion engine. In the first one, we have the explosion, and for the second one, we have the auto combustion. Here we present the different kind of hybrid vehicle. It may be for different mode, that it may be a hybrid electrical vehicle, that we don't use a plug-in electrical vehicle like the second one, and the third one, it is a battery electrical vehicle. Only electricity, we haven't the source of fossil fuel. Here, the other kind of electrical vehicle, which is based on fuel cells. We use hydrogen. We have two types, PMFC fuel cells and IFC fuel cells. But this kind of vehicle, we have many problems concerning the cost and the sensibility of this kind of electrical vehicle. So the problematic for the hybrid car, and we have the plug-in hybrid car, which it need to charge the battery in the station. So we have a cost. So that we need to integrate, or the integration of the PV panel. But when integrating this PV panel, also we have the hybrid car, so we use also fuel. So we need the management of these different sources. Also, to to integrate the PV cells, we have the two constraints concerning the valuable surface and the admissible weight. So we need to study these different parameters in order to improve the PV, to improve the hybrid performance of the vehicle. Here we present the operating principle of solar cells, which is based on the sunrise, and we have the electrical circuit. For the fuel cells, which is based on silicon, we have two types that different only in the efficiency. For the monocrystalline, we have high efficiency. When we have make this research, we have make prospection in Algerian market concerning the vehicle or the light vehicle. We have the Suzuki Alto 800, and we have tried to how to equip this vehicle with system or hybrid system and the PV panel. We have the available surface on the roof and on the hood. Here we have the diagram of electrical vehicle which is equipped with solar panel, because we have plenty of sun in the Algerian Sahara or in the region of Jeddah. So the hybrid car, we have different kind of how to equip this vehicle. It may be parallel, series, or the mixture between parallel and series. Here we have the different model or the equation and the model in Simulink. We have the result of the PV panel and the different calculation of the number of PV panel. Here we have also because the solar panel we have a different solar irradiation, so we need the maximum power point tracking. Then the battery model, we have the different equation and the model of battery. Also the charge and the discharge of the battery. Because the power of solar energy is low, so we need a booster to synchronize between the need of the vehicle and the battery. Here we have then we have the electrical model of the electrical motors. Here we have the complete system which contains the PV panel and the control of system, the battery and the electrical motor. Here we have the complete model which contains the input and the output.
Dr. Boubacar, 2 more minutes. Doctor?
We have the complete system in Simulink, and the result and discussion concerning the result of the different part of the the output and the result concerning the battery. Here we have the booster. Here we have the DC motor. Here we have the different result of the electrical motor according to the torque. And here we have the characteristic curve for the combustion engine. And we have the different variant concerning the integration. It may be 20% or for the second and 100% and the different impact for the vehicle. As conclusion, the available surface allow only 3 for 100 watt PV model. This lead to use the parallel hybrid system. The PV power is insufficient to operate directly to the electric motor, so the booster device is integrated. The unit battery weight about 12 kilogram make an obstacle to increase the number of battery more than 12. So the motor operating time is limited. To overcome this constraint of battery weight, it is recommended to use light material in vehicle construction. And in the end, I have chosen a beautiful image or a photo concerning the ancient transport in the past.
Thank you very much, Dr. Boubaker. Thank you very much. The speaker is now accepting questions.
Thank you, Doctor. And I think solar energy project is very important for human. And I think many of direction about many dimension about the problem. And I think if we success about how to transmit the power wireless, this is a good solution for the problem of solar energy. The solar energy is not new projects, but I think the first project recorded in the humanity, I think in 1883 by American scientist. I didn't remember the name. But maybe there's a problem about how to storage, and if you success to transmit the power wireless distance, huge distance or big of distance, I think we not need to huge of storage capacity such as battery or whatever. I think that, but your work is very important, and I think is a very great work. Thank you very much.
Thank you. Yeah, but we haven't a question normally. We have intervention. You need. I recommend. The distance between the PV panel and yes. Yes.
To create solar energy and transmit it for Europe.
Europe.
This is a big project from 1986. approximately.
Yes.
Yes.
In the past.
And the problem about how to transmit this power without cables, how to transmission without cables. If we success transmit power wireless and without magnetic impact, maybe we success in this in the project of solar project.
Yes. I think we haven't relation between my work, but it is a general question. You can transport electricity from consumption. Yes. We can transport these. Mainly, I haven't understood exactly your question, but generally, we can transport electricity from Algeria via the Mediterranean Sea, but we have some losses concerning the distance between Algeria and Europe. Excuse me. Can you excuse the audience? Can you give me the question in Arabic? You tell that my second language is French. French.
Yes. Not ask you, but to illustrate your work is very important. Yes. About this, the energy, the solar energy is very important for humanity, and this is my comment, not only, and this to expand your work and to continuous effort of this work. Thank you very much.
Thank you very much. Thank you, Dr. Boubacar. Next is Dr. Rayyan Noor presenting his paper where he addresses challenges in handling the exponential growth of AVL, which is automatic vehicle location data from buses during Hajj, emphasizing the impact on accurate travel information using Matplotlib and OpenStreetMaps techniques. He visualizes data during Hajj 2019, aiming to extract movement patterns and identify congestion points for improved service operations. Dr. Rayyan?
طيب السلام عليكم ورحمة الله وبركاته. This is my pleasure to be with you today, and thank you for Jeddah University to give us this chance to participate in this very helpful and nice conference, and I hope it's continue. My name is Rayyan Noor. I am a PhD in computer science and engineering. My topic today about the visualizations of the GPS for the data for understanding the patterns for the bus moving in Hajj. بالعربي، بس أنا جاني واحد من الطلاب كانت في ملاحظة بيقول لي دكتور السبيك كله بالإنجليش، وإحنا كطلاب فمننا فاهمين اللغة الإنجليزية، فالموضوع حقنا إحنا بنحلل بيانات الباصات في الشاتل باص في النقل الترددي في الحج عشان نحسن عملية اللوجستيك في المشاعر المقدسة. ممتاز؟ فحنبدأ اليوم. طبعا this is my research outlines. It was my postdoctoral research in Al-Qura University. Alhamdulillah. And this is my pleasures. I thank Allah, Alhamdulillah, to give me this chance to work in Hajj project. Because this is chance for us, because we are a Muslim people, so we support our Muslim society. طيب؟ وعلى قول المثل بيقولوا أهل مكة أدرى بشعابها. صح؟ فحقيقة you cannot understand the Hajj, especially for the logistic, unless you work in Hajj. طيب؟ Because you have to be like involved in Hajj to understand how the Hajj is moving, right? So my research background, also I give the aims for my research, our methodology. We divided our methodology we use 3 methodology. We use the big data platform for the TensorFlows. Then we propose for the hyperlearning methodology. Then we make some simulation for the traffics and results and discussions and our recommendations. So I give you just brief about our challenge in Hajj. So Hajj, this is special event. No any event in the world, they have the similar case for Hajj. Even for Olympic, even for World Clubs, they don't have the same challenge for Hajj. Why? Anyone here know about why the challenge in Hajj? Just I give you 2 points for the challenge. Especially for مشاعر المقدسة, مزدلفة, منى وعرفات, they have a limitation for the boundary. المساحة 7 كيلو فقط. طيب؟ الأعداد بتوصل ل 3 مليون حاج. طيب؟ فعندنا الboundary, allocations, وanother challenge الtime. النفرة والحج, they have to move in the specific time. قبل غروب الشمس, بعد غروب الشمس. فهذه 2 main challenge. We try to improve the schedule for shuttle bus. So the data increase every day, as we know, and our data we collect from the GPS, especially for the shuttle bus. So we use the huge data. We take our data from النقابة العامة للسيارات. طيب? And this is just we consider our use case about the shuttle bus, النقر الترددي في الحج, مزدلفة, منى, عرفات. So our purpose for our research to improve the schedule for the shuttle bus, to minimize the waiting time for the passengers, and also to minimize how many buses we need to use, right? So they have a huge amount of data, but the problems, we cannot understand the pattern or how the buses move in Hajj. So our research aim, as I explained, we have this challenge, and we need to help the decision maker people to improve the scheduling for the shuttle bus, also to minimize the times and how many buses we need to use to transfer this الحجاج or pilgrims. So based on Saudi visions for 2030, as we know, we need to increase the number for Hajj. So we have to improve the Hajj journey. طيب اللي هو رحلة الحج, we have to improve, we have to give him very good experience journey for Hajj. So we have a big data for the GPS data. We clean the data, then we to integrate it and migrations with our big data platform. We use the TensorFlow. Then we introduce the interactive platform and prepare and make our simulations. So this is our methodology. We divide it for 3 sections or 3 steps. First of all, we build the structures for our big data platforms. The Naqaba, we collect the information from them, and we use our API for Naqaba. Then we build our clusterings and big data platform. We use the TensorFlow. The next one, we propose the hyperlearning method. This is we combine between 2 different algorithms or technique. We use the classification, and then we use the clustering. And the last one, this is the traffic simulations. We try and we do some use case. We select some office, we call it this office, for the shuttle bus, and we try to simulate to find the best numbers of bus and waiting time. So this is the discussions and result. As I mentioned, we have the big data platform. The data was in MySQL, and we make migrations with our platforms. Then in the number A, this is the GPS data characteristics. What is included in the data? It was the GPS ID, and we have the bus number, and we have the time stamp, and we have the longitude and latitude. This is the خطوط الطول وخطوط العرض, okay? And then we have, for example, the speed for the bus. What we found like the outliers. You know, the GPS data, they have a lot of outliers. They have a lot of noisy data. So we have to clean. We clean the data. We can see in the section B, so there is a lot of noisy. This the map, we can see the GPS show maybe this is in Africa. So this is in data science, we call this outliers. So we clean the data, then we make the classification. We need to find the bus stop locations and movement, so we can understand the movement pattern in Hajj. So based on that, we try to extract new feature from our data. We make some use case. We need to find why bus stop here, okay, and how long it stop in these locations. Yes, sorry. No. I cannot go back. From where I can, yeah, go back. Sorry. Yes, this one, yes. So this is the extract for the top bus. We can we get the top 5 bus. This is the examples. And this is we visualize the most of the top bus stops and the speed. And we can found in the left maps. So where is the bus moving from مشاعر مقدسة لمكة, and come back again. This is from stop waiting in Arafat. And we found where is the location was a stop and how long. So for example, the bus number 1, okay, we found bus number, for example, 8007. It was just the total stop 6 hours and 29 minutes. People who went in the Hajj and they use the bus, shuttle bus, they know how much troubles and how much congestion in the bus and how long it take to move just for small destinations. Okay? So we found this kind of patterns. This is our result. We make some simulations to optimizations the scheduling. For shuttle bus, we take our use case, we take the 7 office of the Bulgarians, and we take the Southeast Asia state. So in the left tables, we have, for example, the number of the bus and the waiting time, and we try to propose the optimal numbers of the bus based on assigned for each office. And in the chart below, this is we found how many hours the passengers or the passengers they are waiting for the bus, and the main purpose for this and the main purpose for our project, we built a platform to use with any new data, any new bus data. We can just apply and we can just get this kind of result. This is our recommendations. We built our platform. The platform is existing now. They used to improve the scheduling and make optimizations, minimize the times, and also minimize the bus for the inside مشاعر مقدسة. Thank you very much, and thank you giving me this chance to present our paper and research. And it's my pleasure. Any question?
Thank you very much, Dr. Rayyan. We're going to keep the questions short because we're running out of time. So if anyone have a question, please make it a short question. Anyone have any question? No? Thank you very much. Thank you. Thank you, Doctor. The next paper, Analysis of Companies' Logistic Performance by Using Maturity Model Approach, a case study at a company in Indonesia, will be presented by Dr. Qurtubi. The study assesses the logistics process maturity in a furniture production company using the logistics maturity model, identifying 4 processes with values below 3. It proposes short time improvements for these processes and outlines a medium-term strategy for post-implementation enhancements. Dr. Qurtubi, please. Would you like to have this?
Yes. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I would like to present our paper with title Analysis of Companies' Logistic Performance by Using Maturity Model Approach, a case study at a company in Indonesia. Okay, introduction. A maturity model is one of the techniques to perform capability measurement by assessing each process maturity. According to Batista et al., the biggest problem a company has is the ability to identify the main cause of a low performance level. Therefore, the maturity model assessment is designed to enable a company to assess the degree of maturity of one or more business process, identify the most appropriate activity to a certain work indicator, evaluated the possibility of implementing best practice to improve the maturity level of a certain business process, and comprehend the direct or reverse correlation among indicators and various business process to get comprehensive perspectives toward the impact of every improvement action. The objective of this research is to assess the level of maturity of the logistic business process in a company that produces furniture, as well as to suggest the improvement for maturity value under 3. Research methodology. The research is initiated by identifying and formulating the existing problems in the company. It is conducted to determine items that should be examined and solved. Later, a study of existing literature was conducted to understand possible method for data processing and analysis. The focus of the research is on logistic business process and maturity model. Later, data collection in the logistic process is performed and applied to direct interview with an expert. The next process is to identify KPIs to measure the logistic process performance. Furthermore, the design of a maturity model is created. As this research employs logistic maturity model, or LLM, is distributed to the company's expert to generate maturity process and maturity output for every logistic process. The result of LMM is then analyzed to determine the maturity level below the threshold. Then the improvement is proposed to address the logistic process. Result and discussion. Identification of logistic process and KPI of logistic. From the difference between the logistic process and supply chain process. Yeah. The supply chain process is more focused on production flow or make, while the logistic process is focused on storage or inventory. Identification of the logistic process is next in line by performing an interview with source from the company. From the interview, it was selected 10 process out of 16. Those 10 process are explained: area plan, process demand planning, DP, search, process supplier management, SM, procurement planning, PP, procurement batch management, PBM, area inventory, inventory management or IM, inventory control, IC, warehousing, WA, and then area distribution. Process is shipment planning, SP, transport management, TM, shipment batch management, SBM. So the KPIs, DP forecast accuracy, SM supplier qualification, PP establish procurement plan cycle time, PBM receiving product cycle time, IM stock holding cost, IC inventory accuracy, WA inventory turnover, SP delivery scheduling, TM transportation cost, and SBM on time deliveries percentage. A pilot study test was conducted to test whether the LLM questionnaire is valid or not. Yeah. The method of validity test includes two stages. The first is designed for ordinary people who have logistic-related knowledge, while the second stage is addressed to people who are causally related to the logistic field. The output maturity data are obtained from the data calculation based on reference and validated by conducting interviews with experts. Analysis of maturity process data. The maturity process is obtained from the result of the questionnaire distribution to the company source. Figure shows that value of maturity output at its logistic process is increasing. For DPS3, for SM, for DP is 3, for SM is 3, for PP is 2, for PBM 4, IM is obtained with a value of 2. The output for IC is calculated as 2. The maturity output for WA is 3. SP is determined as 3. The maturity output for TM 4. Finally, the value of maturity output for SBM is calculated as 3. Analysis of output data. Maturity output is obtained from calculation, result, and direct interviews with company source. Figure shows it possible to identify the value of maturity output for each logistic process. For DP is 5, SM is 3, for PP is calculated as 4, PBM at 4, the maturity output for IM is 4, while the value of IC is 5, the maturity output for WA is 5 and 4 for SP. The maturity output value for TM is 4, while SBM is 1. Yeah. After obtaining the entry value of the maturity process and output, the next step is determined as a comparison between those two maturities. There are 4 logistic processes that have a value of below 3, which need improvement. They are PP, IM, IC, and SBM. On PP, IM, and IC, the maturity process value hits below 3. It is main logistic process need adjustment. The improvement of work indicator. Number 1, strategies for short term. Number 2, strategies for middle term. For the short term, for VP, the value of the maturity process is to manage, establish program and plan cycle time, and should be made by management is determining the process limitation of the program and plan by assessing material to several sections. For IM, the value of the maturity process is calculated as 2 minutes. Companies could increase their cost effectiveness and enhance their efficiency in material procurement, as well as in utilizing space in warehouse and management to assign a team responsibility for calculating EOQ. The value for IC is 2 minutes. Establishing the standardization in inventory accuracy calculation, a cycle count could be used method to measure inventory accuracy. And the value of maturity output for SBM is 1. It means that the management must consider increasing the output of the one-time delivery percentage. Management should to performing monitoring and controlling towards product delivery. It is designed to maintain the product delivery functionality and to avoid a decrease before its improvement. Strategies for medium. Management creates a business improvement BIT. The logistic process that are involved in this category are DP, SM, WA, and SP. Eventually, entire logistic process in this LLM process will become systematic, measurable, and effective. BIT is expected to perform a similar audit on the business process of production size.
Doctor?
Yes. Okay,
yes,
thank you.
time's up. If you can close. Okay, thank you very much, Dr. Qurtubi. And we can take a very short question, if any. Okay, thank you very much, Doctor. Thank you. Issues and opportunities. Research in the field of logistics performance is the next paper presented by Dr. Jundi Al-Qutb. This literature review, based on 27 articles, highlights research opportunities in logistical performance, suggesting the need for an integrated framework in production systems, inclusion of additional variables in retail logistics models, and expanding research across countries and industries for more comprehensive insights. The study also advocates for analyzing the financial impact of key risk factors and safe inventory levels on performance. Doctor?
Assalamualaikum warahmatullahi wabarakatuh. Thank you for everyone who comes to this agenda. Also, thank you for University of Jeddah that already held this agenda of International Conference on Logistics. Here I want to share about my presentation, about paper, the issues and opportunities research in the field logistic performance. We are from Universitas Islam Indonesia. Okay, this is for the presentation outline. I will explain what is the introduction or the background of this research, and then after that, I will explain what is the methodology that we use in this presentation, and then the result and discussion of our research, and the last is the conclusion. Okay, as we know, the logistic is defined as procuring of the raw materials, procurement, goods transportation, storage, and interrelated information flow through the organization and its marketing channel to their distribution to exploit the profits. And then the purpose of or the aims of this research is to know what is the development of logistic performance measurement that we can conduct in the future later. Okay, this is the methodology of our paper. We use the traditional literature review stage. The first stage is to planning the stage. We formulate the review research question about what is the topic of the research, and then what are the parameter. And then the next stage is the execution or the conducting stage, which are we identify where is the literature review that relevant with our research purpose. And then in the last, we are conduct the reporting stage. We review and classify, and we make a report and discussion from our literature review. And this is the result. We got about 27 articles that start from 2008 until 2019 that have been identified and found, and already we analyze about the logistic performance and marketing performance. Okay, for the first research in the first years, this research tell about the quality, performance, and productivity, and then what we can develop later more. It's about we can integrating the product system and quality control to be a system parametric for the logistic parameter measurement. And then in the second years, or the 2009, we suggest for the hybrid method, integrating for the fuzzy logic concept, process optimization, and the theory of utilization to model the customer preference and determine the level of station utilization. And then in the next stage, in 2011 until 2013, we found 3 articles. In the first article, it said there is a correlation between service capability and the performance of third-party logistic provider, or 3PL. In the second research, we need to develop a logistic benchmarking framework to make new measurement, logistic performance measurement. And then in the third research, we got the new insight to make logistic performance in the terms of effectiveness. Because in the previously, we just found about the article that just concern in the terms of quality of the research object. The next, in 2014, we need to highlight about the 9 parameters, or we make a group to make it easier based on the past performance result. And then in the second research, we know about the parameters or variable is economic and environmental performance measurement. So it was called as multi-methodology in supply chain management or logistic. So we must integrating 2 of them. And then in 2015, we got 3 articles. The first, we need to give or make the collaboration between the loading and unloading interface. And then in the second research, we need to add more variable, and we involve another variable such as the trust, purchase intention, and commitment of the customer. And then in the third articles, we need to involve the global competitive index on the LPI dimension, such as we can make improvement in logistic service. That three dimension is the international transportation, tracking, and functionality. And then in 2016, the first research is about there is a significance between two countries. In here is the German and Turkey. So from this research, we can give a recommendation about we need more involved another cities or another countries. And then the second research is we need to involve the 6 component of logistic performance indicator, and then we need make the more consistent and then more clear benchmark to make the result of our logistic performance is more accurate. And then in the third articles, we need make a new module that is used to predict logistic performance. And then in the fourth research, we use the indicators on logistic performance and conducting the national logistic staging. So it's not just about the company logistic performance, but overall of this country. And then in 2017, we use the allowance-based measurement, SBM, of the data involvement analysis. So it can make a better performance developed by the countries. And then in the second research, we can develop the methodology of measurement is that we use 2-stage methodology framework. The first is the framework stage, and then the second is the potential elaboration stage of multivariate adaptive regression spline or MARS. In the next, the third research, we use the sustainability supply chain and environmentally friendly logistic flow. It's include of recommendation based on the involving the variables. And then in the fourth research, we need to carry out an in-depth and broader analysis of the. In the 2018, we make the new method to evaluate the general performance of decision making. And then in the second research, we need to make like some binary integer program. And then in the third research, we need develop 4-tier logistic performance assessment framework. In the fourth is we need to more attention about the cost calculation and the logistic inventory levels. In the fifth, we need concern about the correlation of logistic performance and environmental degradation. And then in the sixth, we research about the infrastructure and tracking and tracing. In the seventh article, we need to concern about the trend and patterns of this logistic performance measurement to combine the relationship between these two things into the indicators that can improve our measurement.
Dr. Jundi, 2 more minutes.
Okay. And then in the last years, we found 2 articles. In the first articles or the research, we need to including several criteria that involve in the sustainability of national logistic performance. And then in the second research, explain that we need use like the multi-criteria decision making. That multi-criteria decision making can be used to assess which is the most criteria that it's more important than another. For the example, to be increased in the form of inventory optimization or distribution activities. And then for the conclusion, we need for the future research about the logistic performance, we need to include other variables in the model, and then we need to include various countries or cities to make it more big scale to get more accurate data. And then for the last conclusion is expanding the analysis of the outcomes of logistic performance on international trades. I think that's all from my presentation. Thank you for your listening.
Thank you very much, Doctor. Thank you. If any questions? Any questions for them from the audience? Thank you very much, Doctor. Thank you.
The last paper in this session, Bus Operation Modeling Using Semi-Open Queuing Networks, will be presented by Dr. Fakhruddin Eldemir. In 2022, a new public bus system was introduced in Mecca during Ramadan to facilitate Umrah pilgrims. However, due to heavy demand, traffic conditions, and lack of established measures, KPIs were not measured. The article proposes a semi-open queuing network model utilizing real data from intelligent transport systems and field observations to estimate and report system performance measures, including passenger serving capacity and queue characteristics. Dr. Fakhruddin, please.
Thank you very much. Okay. Now I would like to start that Hajj is an important part of this, challenging part in this environment, but another time period is the Ramadan period where we have great challenges. And we have used math to model the problem itself and try to find some solutions out of that. So I will start with introducing the problem. Then I will discuss our queuing model. Then our steady state calculations. Based on our model, we are going to give some solutions to the problem that we had in Mecca. All right. In 2019, we had, or 2020, this COVID, and we had lots of restrictions about Masjid Haram during Ramadan in 2020 and 2021. And 2022, these restrictions are released a little bit and brought new problems. And during that Ramadan time, 400,000 people during the holy month visited Masjid Haram, and the transportation became major issue, especially during Taraweeh times. All right. Based on Vision 2030, a public transport project taken to the place. Now in Mecca, we are having buses being operated, and that time the company had big problems, issues, faced serious problems when the demand increased suddenly, where all the other buses are taken out of the operations from the other companies. So it was the public buses that started in 2022. And there was very high passenger demand, and the traffic also during the Ramadan is very difficult in Mecca. This study had provided a quantitative analysis using network models and queuing network models. We look at the service level, passenger waiting times, bus utilization, and we use these performance measures to improve the system. All right. So in Ramadan 2022, only 2 lines operated. One of them goes from train station, Haramain train station, to the Masjid Haram. The other one is Tanim Masjid. And they were started operating. And this is the bus stop at Jabal Omar. And this was main area that we worked, and especially the queue sizes, how long people are waiting, and what would be ideal bus numbers these things that we were trying to answer. And the other side was the Haramain train station. And the more buses that we introduced into the system, we realized that there are bottlenecks are appearing, so the ideal bus numbers should be there. And also, resource utilization is very important. The resources that we didn't utilize efficiently means that we are not providing services to the people in the other sides. And this is the map for the Route 7A. Approximately it was 12 kilometers and with a certain number of bus stops. Okay. So I will just look at, we modeled this problem in queuing modeling perspective. And if we just consider the passengers, it is open queuing networks, meaning that passengers are entering the system, taking the service, and leaving the system. By looking at the only buses are always operating in the network, and so it is closed network. When you consider those networks together, those queues together, we call it semi-open queue models. And so for us, the most important part was Jebel Kabe station. So we took that as one station, and the remaining bus stops, we modeled them as a one node. And the Jebel Kabe turned out to be, or we were able to model it as MM1Q with limited number of servers or buses that are coming there. So N buses, the capacity is N, number of buses in the system is N. So it could be general discipline, and Markovian systems or Poisson process can be used in this modeling. And if you look at the node 2, it is again similar queuing model where we have N servers, which is number of buses, and queue capacity, and the system capacity is N. And we developed steady-state diagrams for Jebel Kabe station. And when we have 0 buses, 1 buses, 2 buses, and so on, and we wrote transition diagram, and using these transition diagrams, the arrivals rates and input rates, assuming that they are equal to each other, we were able to develop the probabilities as a function. Therefore, we use these functions to calculate the probabilities, and similar for the other stations, this is what we have done, and we calculate all steady-state probabilities. After calculating steady-state probabilities, we were able to calculate based on number of vehicles, how our capacity is going to be affected. As you see, increasing number of vehicles after 25, for this specific case, we're not increasing the capacity a lot. So we were introducing extra bus traffic, although we were not providing the capacity. And probability of seeing no buses at this station decrease very low level when we had around 25 buses. And when we look at the Mecca example there, we had arrival distribution, and we used Poisson process, exponential service times, and in some cases Erlang service times, arrival rate, and so on. And the dwell time and trip cycle time, we introduced it. And we collected some of these data from passenger counting systems and also AVL, GPS systems, and these values are entered to our mathematical model. And we calculated the average waiting time, how many buses are available there, and what are the Jebel Kabe station utilization, and so on. We had seen that dwell time is an important factor. As we increase the dwell time, which is loading and unloading of the passengers at this station. As this increase, the capacity goes down, and probability of having no buses at the station available increases, and so on. Also, we look at how the cycle time might affect the capacity and probability of having no buses at this station. We analyze this one as well. And at the end, we try to provide a guide for the number of buses if we want to reach 95% service level at the station for different cycle times, how many buses we should provide into this system. Now, as a conclusion, we had seen that one loading, unloading point, which is the dwell point, is not sufficient, and they were using two, and it was clear that the more dwell stations we had, the system performance is going to be high. And we had seen that the system capacity is mostly affected by the dwell time, so loading and unloading process has to be improved there a lot. And the results that we obtained in this analytical model is consistent with the results that we observed. In addition to that, the analytical results that we had obtained can be further expanded by using advanced simulation models. Thank you very much for your attention. And if you have questions, I will get just a short question. All right.
Thank you very much, Dr. Fakhruddin. Thank you. As we draw to a close, I'd like to extend my heartfelt gratitude to our esteemed presenters for sharing their invaluable work with us today, and to our attentive audience for their active participation. Your contributions have enriched this logistic conference, fostering collaboration and innovation in the field. Thank you all for making this event a great success. Thank you. والآن فليتفضل عميد كلية علوم وهندسة الحاسب دكتور عبد الوهاب المزروعي مشكوراً، ووكيلة الكلية للبحث والابتكار دكتورة إيمان الظاهري لتكريم الفائزين بجائزة أفضل بوستر. البوستر الفائز بجائزة أفضل بوستر Smart Container Solution. فليتفضل مشاري عبد الله، عبد الرحمن الغامدي، عبد الرحمن العربي، يوسف النعماني، غازي مكاوي لاستلام شهاداتهم.
As we come to the end of our conference, I want to express my sincerest gratitude to each and every one of you, and every one of our participants and contributions. I would like to extend a special thanks to our speakers, our organizers, for their invaluable support in making this conference a resounding success. Thank you once again for your presence and your dedication. Safe travels, and until we meet again. Assalamu alaikum wa rahmatullahi wa barakatuh.